तो मैं उम्मीद करता हूँ कि सब लोगों को ऑडियो वीडियो क्लियर है. एक बार प्लीज कंफर्म मी whether you can hear me or not. Am I audible? Good evening everyone. Good evening. So in today's session we'll discuss about previous year questions of network theory again, and in today's session we'll discuss mainly for ECE students. There were some questions from EE background also. For EE student there were some questions which I need to discuss, so I'll discuss those questions also. Okay, so this session is important both for EE and ECE. Okay, so both students have to attend this session. Good evening, Ravi Shankar. Good evening. Is audio video clear to everyone? Tell me guys, is audio video clear to everyone? Is audio video clear? Good evening, Madhu. Good evening. PDF, have you uploaded, sir? No, I have not uploaded the PDF, but yes, I have saved the PDF. I can share it on the Telegram group if you want. So I'll share it on the Telegram group. Okay, no problem. So let's start the session, guys. Let's not waste the time, and let's start the session. So this is my introduction. I hope everybody know me, but if you don't know me, then I teach almost each and every subject, and right now I'm teaching network theory, and I'm solving PYQs for last 5 years. So before starting the session, please subscribe our channel if you haven't subscribed it, and like this session and press the bell icon so that you get the notification whenever my video will be live. Okay, so for GATE 2024 students, there is a workshop which is going on, and this workshop is taken by DV Sridhar sir. So you can recommend this workshop to your juniors, to your friends, and this workshop will be on 27th of December at 8 p.m. Okay, the link is given in the description of this video, so you can register from that link. Okay, now let me tell you guys, this is about test series. Now it's time for the test series, so better you start giving the test series. Test series will tell you about your mistakes, about your you can say your score, and about your speed, accuracy, everything. Okay, so start giving the test series, join the test series. BYJU'S Exam Prep is also providing you the test series which is according to the GATE exam, so you can join that series. It's not that much costly, and start giving the test so that you can analyze yourself. Okay, you'll get at least 60 plus tests, in which syllabus subject wise tests are also there. Some mock tests are also there, so you can take the advantage of that. Okay, so I think it's time to start. Tell me guys, can I start? Can I start the session? Tell me everyone, you ready? Now this time, okay, in previous session mainly I solved the question. Actually my health is not with me, I'm not feeling fine because cough is the main problem. In yesterday's class also I was not well, so anyway I took the class and I solved the questions. But in today's class I want you to solve it. Okay, let's start this question. Now tell me, in this question R1 is given as 1 ohm. This is 1 ohm, this is 1 ohm. Okay, let me write it. Okay, in this question this is 1 ohm and this is 1 ohm, and here you have again R1, 1 ohm, 1 ohm. This is also 1 ohm, 1 ohm, and now you have R2. So R2 is 2 ohm, this is 2 ohm, this is also 2 ohm. Now what about R3? R3 is 3 ohm, this is 3 ohm and this is 3 ohm. What I need to do is I need to calculate the current I. This is 11 volt and I need to calculate this current I. What is this current I? Okay, so how to calculate that? It's very simple. You need to calculate the equivalent resistance of this network. If somehow you can calculate the equivalent resistance of this, then 11 divided by that equivalent resistance, you'll get the current. Okay, now can you tell me how much current will flow? Tell me guys, what is this current? What is this current? Can you tell me how much current will flow? Tell me guys, tell me everyone, how to calculate the equivalent resistance? What is the equivalent resistance of this network? Equivalent resistance of this network. Can you solve it? Everyone, do it. Do it, and then after that I'll maybe after 1 or 2 minutes I'll try to solve it. Okay, so till then you can try this. It's a very easy question. It's based on equivalent resistance. Now I want to see how many of you are able to calculate the equivalent resistance of this network. Tell me guys. Tell me what is the equivalent resistance You want me to solve it? Tell me, everyone. You want me to solve this question? Okay, let me try. Okay, let me try this question. You want me to solve this? Tell me, everyone. You want me to solve this? Please tell me in the comment section. Nobody is replying. It means you are not solving. Okay, let me tell you. Let me tell you how to approach this question. How to approach this question? Let me tell you guys. Look, this current is I. This current is I. Now at this point, this current has two paths. Okay, try Ravi Shankar, no problem. And let me try also so that we can match the answer at the last. So let's say this current is I, and this current I is dividing in two paths. But if you see carefully, this structure is symmetric in both the sides. In this side also and in this side also, the circuit looks the same. Okay. So you can say that this current will divide equally. This current will divide equally, because on this side also, if you go via this path, again you'll see three branches, 2, 3, 1. So you will see three branches. Here also you will see three branches, 2, 3, 1. It means this circuit is symmetric in all aspects. Now what you can do is, obviously this current will be equally divided. So you can say that this point and this point will have the same potential. They have the same potential. Why? Let's assume that this is 0. If this point is at 0 volt, this will be at 11 volt, right? 11 volt minus this drop will be the voltage here, and 11 volt minus this drop will be the voltage here. But we know that since the structure is symmetric, so the current will equally go in two paths. So this drop and this drop will be same. So if you have 11 volt here, you'll have the same voltage between these 2 points. So you can say that you have same potential at these 2 points. If you have same potential at these 2 points, you can remove this resistance. There is no need for this resistance. No current will flow via this R2. Is it fine, guys? Similarly, if I is entering here, I will leave from here. You can say that I will leave from here. And since the network is symmetric, then you can say that I by 2 will come via this and I by 2 will come via this. If this point is at 0 volt, then I by 2 into 1 will be this voltage, and I by 2 into 1 will be this voltage. So you can say that this point and this point will also have same potential. So if they have same potential, then there will be no current in this branch. There will be no current in this branch. Okay. So you can say that. Is it fine, guys? Up to this point, I think there is no problem. So no current in this branch, no current in this resistance. So it will not participate in equivalent resistance. Now we have this circuit. We have two resistances like this. Then at this point we have two paths. Similarly, at this point we have two paths, and then we'll combine. So we need to calculate the equivalent resistance of this circuit. Just remove this 2 ohm, this middle 2 ohm, okay? Because there is no need for this 2 ohm. I hope you understood why I have removed this 2 ohm. Because on this point and this point we have the same potential. Similarly, on this point and this point we have the same potential. That's why. Now, what is the equivalent resistance of this network? What you can do is you can simplify this diagram. You can simplify this diagram. How to simplify it? It's very simple. Start solving using path method. Let's call it A point. This point is B. This point is C. This point is D. This point is E. And this point is F. Okay, if you look at from A you have two paths. You have two paths. One path is via 1 ohm, and the other path is also via 1 ohm. Is it fine? This is via 1 ohm, this is also via 1 ohm. Okay. Now this point is, you can say B. This point is B, and this point is C. Now, from B you have two paths. From B further you have two paths. From B you have further two paths. 3 ohm and 3 ohm. Okay, this is 3 ohm, this is also 3 ohm. Okay, one path landed at E, this path is E, one path landed at E, and one path landed at D. Okay, this point is D. Is it fine, guys? This point is D. Okay, so now I have covered this, and this. Okay, now come to C point. If you look at C, you have again two paths. One path landed at D and one path landed at E. From C, you have two paths. One path landed at E, one path landed at E, and one path is landed at D. So this point and this point is same. So rather you connect it like this, rather you connect it like in vertical form. Okay, this will be more easier. Okay, is it fine, guys? So I call this point E and this point is also E. This is 3 ohm. So from B to E you have 3 ohm, and B to D you have 3 ohm. So let's call it B to D. This point is D, 3 ohm. Similarly, from C to E you have 1 ohm. From C to E you have 1 ohm. Okay, from C to E you have 1 ohm. Wait a minute, guys. I think I have put this resistance wrong. This is 1 ohm. Is it fine? This is 1 ohm. Yes. B to D is 1 ohm, na? Then C to E you have 1 ohm, and then C to D you have 3 ohm. C to D you have 3 ohm. Okay. C to D you have 3 ohm. Is it fine, guys? So I have plotted this. So C to D I have covered this. Now from D to F you have 1 ohm, and E to F you have 1 ohm. It means D and E, D to E to F you have 1 ohm. This is F point, you have 1 ohm. Similarly, you can say from D to F you have 1 ohm. Is it fine, guys? This is the circuit we have. This is the circuit we have. Now we need to calculate the equivalent resistance. We need to calculate the equivalent resistance. How to calculate the equivalent resistance? Tell me, guys. This is not an easy task. Again, the circuit is not that much simple. Okay. Okay. Again, the circuit is not that much simple. Now, let me tell you, using the path method, this is not becoming simple because we can't simplify this circuit. We don't even know how it is going. I mean, which one is in series, which one is parallel. So it's not easy to simplify this. Okay, now how to simplify it? There is one more way. There is one more way. If this is not the right way, if you can't solve via path method, if you can't simplify via path method, then what you can do is you know that this point and this point are at the same potential, and this point and this point are at the same potential. So better you combine it. Better you combine it. Okay. If this point and this point are at the same potential, and this point at this point at the same potential, then you can combine them. There is no problem. Okay. You can make them same point. There is no problem at all. It will not change the current distribution. Okay. So if I do like this, then what will happen is, now from A, 1 ohm on this side and 1 ohm on this side. So now you have from A, you have equivalent resistance as 1 and 1 in parallel. So it will be 1 by 2. Is it fine? Now you can see that this 1 ohm and this 1 ohm are in parallel. You can say that this 1 ohm and this 1 ohm are in parallel. Similarly, not only these two resistances are in parallel, this 3 ohm and this 3 ohm are also in parallel, because actually between this point and this point you have 4 resistances now. 1, 1, 3, 3. So actually you have 4 resistances in parallel now. 1, 1, 3 and 3. Is it fine, guys? Okay. 1, 1, 3, 3. So there are actually this 3 ohm and this 3 ohm. They are in parallel because they have the same point. This point and this point is same now. So this 3 ohm and this 3 ohm, same starting point and same end point. So they will be in parallel. So like this one and this one will be in parallel. Okay. So 4 resistances are in parallel. Now You can see that this one and this one is again in parallel because we have connected this point and this point. So now you can say that again 1/2 ohm. Is it fine, guys? We call it A, we call it F. I think this way it's easy. Is it fine, guys? Tell me, is it fine? Sir, more time taking. No, it's not time taking. Actually, I am taking time. Actually, I am taking time to solve it, because in exam, if this question came, then obviously I will hit like this only. Okay, I know I'll not try this via path method, because I know that this network is symmetric and this point and this point will have the same potential, this point and this point will have the same potential. So I will connect these 2 points. These resistances will be removed. Okay, and then I will try to see which one are in parallel. So you can say that 1 and 1 are in parallel. So I have taken 1/2. Then this one, they have the same starting point and they have the same end point. Similarly, this 3 and this 3, they have the same starting point, same end point. So all these 3, 3 and 1, 1 are in parallel. Now this one and this one again in parallel. So it will be 1/2. So actually I am taking time, but it is not, you can say it's not time consuming. It's simple question. Now what is the value? Now what is the value? 3 and 3 are in parallel. So 3/2 in parallel with 1/2. Now what is the equivalent? 3/2 into 1/2 divided by 3/2 plus 1/2. Is it fine? So here you will get 3/4. 3/4 is this product, divide by 2. Divide by 2. Okay, so it will be 3/8. Is it fine, guys? So you can see that this resistance is 3/8 plus 1 plus 1/2 plus 1/2. So it means you can say that 3/8 plus 1 is the equivalent resistance. So it will be 11/8. Okay. So the equivalent resistance between A and B is 11/8. Between A and B, you have 11/8. Okay. Now what is the current? Current will be 11 divided by the equivalent resistance. So that will be equal to 8 ampere. Is it fine, guys? Have you understood it? Tell me, everyone. Have you understood this? Tell me, guys. So this was again simple question. But let me tell you, you have to solve via equipotential points or symmetry conditions. Via symmetry condition you can solve it. Okay. Let me repeat this again. If you want me to repeat this, let me repeat this again. Let me tell you this question again. Okay. Look at this question again. Let me tell you how I have solved. If you know how to distribute the current, then it will be easy. Then it will be easy if you know how to distribute the current. We know that this current is I. Let's say this current is I. And we know that this structure is symmetric about these 2 paths. Let's say if you go like this and if you go like this, you will see same circuit ahead, and you will see same circuit ahead via this path also. It means the current will divide equally. If the current divides equally and these equal resistances are there, so you can say that the drop will be equal. So this point and this point will have the same potential. So better you connect them. Better you connect them. Because even if you connect them, there will be no change in the distribution of the current. Okay. There will be no change in the distribution of the current. So better you connect them. Similarly, on this side, if I divides equally, so I will meet equally. Okay, this current will join equally. Okay, because it has symmetric structure. On upper side, whatever the shape is, the same shape is on the lower side. So you can say that same current will come via these 2 paths. If this lower point at 0 volt, this point and this point will have the same potential. So you can combine them. There will be no change in the distribution of the current. Okay. So you can say that this resistance is of no use now, this resistance is of no use now, because they have the same potential on both sides. Is it fine? Now, what you can do is, you can name, this point is A, we call it B. Okay, so this point will also be B. This point you call it C. This point will also be C. And you call it D point. Okay, now from A to B, you can see that there are 2 resistances, 1 and 1. So it will be 1/2. Is it fine? So we have covered this and this. Now from B to C, if you look at this, from B to C, you have 1 ohm, 1 more 1 ohm, 3 ohm, okay, and B to C, there is 1 more 3 ohm. So 1133. Okay. Now from C to D you have 1 ohm and 1 ohm. Okay. So you have 1 by 2 ohm. Is it fine, guys? So from A to F you have this circuit. Now you can calculate their equivalent resistance. So the equivalent resistance came out to be 11 by 8 ohm and the current will be 8 ampere. Is it fine, guys? It means you have to be attentive. Okay, you should know that these 2 points should be at same potential, so you can connect them. Is it fine? Is it fine? You can apply this condition, and I hope you understood it. Okay, can I proceed? Can I proceed, guys? Let's move to the next question. Yes, you can see the next question. For the circuit given in the figure, the magnitude of the loop current 0.5 second after closing the switch. Okay, after closing the switch, after 0.5 second, we need to calculate the current value. So now how to calculate this current value? After closing, we need to write the current equation. What is the initial current? This is RL circuit. Okay. In this RL circuit, the initial current is 0. Initial current is 0. Now, what is the steady state current? If the switch is closed for a long time, tell me how much current will flow. The steady state current will be 1 divided by the total resistance 2 ohm. So it's 1 by 2. Steady state current is 1 by 2. Now, what is the time constant? Time constant is L divided by the total resistance of this path. So 1 by 2. L is 1, R equivalent is 2 ohm. So you can say 1 by 2 is the time constant. So the current equation IT will be equal to I infinity plus I0 minus I infinity e to the power minus t by tau. This is the current equation. Take this 1 by 2 common, 1 minus e to the power minus 2t. Is it fine, guys? This is the current equation. After closing the switch, this will be the current equation. Now I need to calculate the current at t equal to 0.5 second. So put t equal to 0.5. So if you put t equal to 0.5, you will get 1 by 2 into 1 minus e to the power minus 1. This much of ampere will be the current in this circuit, current in the loop. Is it fine, guys? So this way you can solve it. I think this was easy peasy again. Can I proceed? Tell me, guys, can I proceed? Let's proceed with the next question. Let's proceed. Okay, Vishwanathan is saying 0.316. Its value is 0.316. Oh, it's okay, whatever. Okay, just calculate this value. I'm not interested in the answer. Anyway, try to solve this question. Try to solve this question. Again, it's very simple question. The question is for the circuit given below, given in the circuit, given in the figure, the voltage VC across the capacitor. We need to calculate this voltage under steady state. Under steady state, we need to calculate this voltage. So I think it's easy peasy. How to calculate this? Tell me, guys. First of all, calculate this reactance. Reactance is 1 upon J omega. Omega is 5 into C. C is 10 raised to power minus 6. Is it fine? So this much of ohm is the capacitive reactance. This is the capacitive reactance under steady state. So if you simplify it, you will get 2 into and there will be 5 zeros. Okay, there will be 5 zeros minus J. Is it fine, guys? This much ohm is the capacitive reactance. Is it fine? This is the capacitive reactance. Okay. So 2 into there will be 5 zeros because 10 raised to power 6 will come in the numerator. No? So I took 110 away and then 10 raised to power 5. So that 2 into 10 raised to power 5. This will be the reactance. Now the current IT will be 5 at an angle of 0 divided by, I have written this 5 at an angle of 0 divided by the total impedance, and the total impedance is 10 raised to power 5 plus 10 raised to power 5. 2 into 10 raised to power 5. This is the resistance value minus J 2 into 10 raised to power 5. This is the reactance value. Is it fine, guys? This is the total current which will flow in this circuit. This is the total current which will flow in this circuit. Now I need to calculate this voltage. So this current multiplied by minus J multiplied by the capacitive reactance minus J2 into 10 raised to power 5. Is it fine, guys? This much is the voltage across this capacitor. Now this is the peak value of this capacitor voltage. and we need to calculate this voltage, peak value I suppose, because it is not mentioned whether we need to calculate the peak value or the RMS value. Okay, so let's try to solve this question. So this will be 5 divided by, if you calculate the magnitude of this quantity, it will be 2 into 10 raised to power 5 root 2. And here the magnitude is 2 into 10 raised to power 5. Is it fine? So this will be cancelled, this 2 will be cancelled. So you can say that it's 5 by root 2. So the peak amplitude, this voltage amplitude has the peak value of 5 by root 2. Is it fine, guys? So please repeat fourth step. Fourth step means which step? In which question you are saying fourth step? In this question? Ravi Shankar. Sir, 5 omega can take a resonant frequency. No, in this resonance is not possible, na? Because network does not have inductor part. So you can't say that resonance will take place. Tell me, guys. Laplace, don't go to the Laplace, no. Why you need Laplace? Why you need Laplace? You don't need Laplace. What you need to do is, it's an AC circuit. In AC circuit, you need to calculate the steady state reactance of this capacitor. So the steady state reactance of this capacitor is 1 by j omega c. Omega is 5, you can see that, and c is 10 raised to power minus 6. So I have multiplied with 10 raised to power minus 6. So this value, this j will come in as minus j, and this value will be 2 into 10 raised to power 5. Okay, because this will be 10 raised to power 6 by 5 minus j 10 raised to power 6 by 5. I have written this 2 into 10 raised to power 5. Is it fine? 2 into 10 raised to power 5 minus j 2 into 10 raised to power 5 ohm. This much of reactance is this capacitive reactance. Now, how much current will flow? First of all, try to calculate the current. So the current will be 5 angle 0. Make it 5 angle 0. Assume sinusoidal current and assume sine as reference. So 5 angle 0 divided by the total impedance, and the total impedance is 2 into 10 raised to power 5, 1 into 10 raised to power 5 plus 1 into 10 raised to power 5 minus j into. So you can say that 2 into 10 raised to power 5 is the total resistance minus j into 2 into 10 raised to power 5 is the reactance. Okay, this is the total reactance, the total impedance of this path. Total impedance of this path. So I have divided voltage divided by the total impedance. So you'll get the current. That current multiply by this reactance, you'll get the voltage across the capacitor. Is it fine? But this is the peak value of the capacitor voltage. Why this is the peak value? Because we have used the peak value of the source. That's why you'll get the peak value of the voltage across the capacitor. So this is the peak value of the voltage across the capacitor. Is it fine, guys? Is it fine? So you'll get the peak voltage across the capacitor, which is 5 by root 2. But I think if nothing is mentioned, let's say this letter is given and nothing is mentioned, it means by default I need to put the RMS value. Okay, I need to put the answer as the RMS value, not the peak value. Okay, now how to calculate the RMS value? If this is the peak voltage across the capacitor, then the RMS voltage will be divided by root 2, further divided by root 2. What we have done is we have calculated the magnitude here. The magnitude is 5, and here the magnitude is 2 into 10 to the power 5 root 2. This is the magnitude here, the denominator, and the magnitude here is 2 into 10 to the power 5. So 2 into 10 to the power 5 is cancelled. 5 by root 2 is the peak value of the capacitor voltage. This is the voltage across the capacitor. But we need the RMS value. If nothing is mentioned, it means RMS value is required. So RMS is further divided by root 2. So it will be 5 by 2. 5 by 2 is 2.5. Is it fine, guys? So the RMS value of the capacitor voltage is 2.5 volt. Is it fine, everyone? Can I proceed? Let's move to the next question. Next question is on your screen. You can see that ABCD matrix for a two-port network is defined by, this is the two-port network and its ABCD parameter are given like this. Okay. Look, this I2 is negative. Why it is negative? Because in ABCD parameter, generally I2 should be outward. Since it is inward, that's why I have written minus I2. Okay. So this is the ABCD parameter which is given. The parameter B for the given two-port network. Okay. We need to calculate the parameter B. How to calculate this parameter B? How to calculate this parameter B? It's simple. How to calculate it? If you solve this equation, you'll get V1 is equal to AV2 minus BI2. Is it fine? And I1 is equal to CV2 minus DI2. I need to calculate this B. What you do is you put this V to 0. If you put this V V to 0, it means you sort it. Once you sort it, calculate this I2 in terms of V1, or simply you can say that B is equal to V1 upon minus of I2. So you have to take this ratio, V1 and I2. You have to calculate this ratio. So what you can do is you assume this voltage. No? You assume this voltage. How much voltage you want to assume? Whatever. It's up to you. Let's say we know that the parallel of 5 and 2 is 5 into 2 divided by 5 plus 2. Okay. 10 by 7. Is it fine, guys? 5 into 2 divided by 5 plus 2 is 7. So 5 plus 2 is 7. So it will be 10 by 7 plus 2. So it will be 24 by 7. Is it fine, guys? So we know that the equivalent resistance seen here is 24 by 7. So what we can do is we can assume this voltage to be 24 by 7 volt. Let's say, to make the calculation simple, I assume this voltage to be 24 by 7 volt. So if you assume this voltage to be 24 by 7, then this current will be 1 ampere. Now what about this current? 1 ampere can be divided into this, in two parts. So this current will be 5 divided by 2 plus 5, that is 7. So you can say that this current is 5 by 7. Is it fine, guys? Is it fine? So V1 is, so B will be equal to 24 by 7 divided by minus of I2. Now I2 is in this direction. So I2 is minus of 5 by 7. Is it fine? Minus of 5 by 7. Is it fine, guys? Minus of I2. B is this, na? Take this minus of I2 downward. So V1, B is equal to V1 upon minus I2. So we know that I2 is in this direction. And this direction current is 5 by 7. So I2 is minus of 5 by 7. So I put I2 as minus of 5 by 7. So it will become plus here. And this 7 is cancelled. So you can say it will be 24 by 5. So B will be 24 by 5. Is it fine, guys? Tell me, have you understood this? B is 24 by 5. We can assume this voltage whatever you want. Let's say take it 10 volt, 20, 30. Why I have taken this 24 by 7? So that the calculation becomes simpler. Okay. Because I have calculated the equivalent resistance seen from this side. Equivalent resistance came out to be 24 by 7. Okay. Equivalent resistance came out to be 24 by 7. That's why I have assumed this voltage as 24 by 7. Then the current will be 1 ampere. And this current will be divided again at this circuit. So I2 came out to be minus 5 by 7. Is it fine? I2 came out to be minus 5 by 7. I put it here. And V1 is 24 by 7. Calculated this B. Is it fine, guys? Tell me. Can I proceed? I think this is again easy peasy. This is again easy peasy. You can easily solve it. And you can calculate the B value. Now, let's come to this question. This is not a circuit theory question. But anyway, the typist did it in the circuit theory. So let's try to solve it. The circuit shown, Vs is 10 volt. Okay, this is the supply voltage Vs. Vs is a square wave and the peak value is 10 and then minus 10 and then 10. It is like this. And the time period is 4 millisecond. Time period is 4 millisecond. So it will be 2 millisecond. This point will be 2 millisecond. Is it fine? Okay. R is 500 ohm. This is 500 ohm. Okay. And C is 10 microfarad. 10 microfarad. C is 10 microfarad. Fine. The capacitor is initially uncharged at t equal to 0. At t equal to 0, this capacitor is uncharged. The diode is assumed to be ideal. This diode is ideal. The voltage across the capacitor we see at 3 millisecond. At 3 millisecond, it means at this instant, I need to calculate the capacitor voltage. What will be the capacitor voltage? Now, how to calculate this capacitor? It's simple. Initially, it is 0. So, let's assume that this is 0 volt and this is VST, obviously. If this is 0, this will also be 0 because capacitor was initially uncharged. So, you can say that if this is 0, then this point will also be 0. So, the upper point is 0 and this side we have VST. Now, the diode will conduct if VST is greater than 0. If let's assume the diode is not conducting initially. If diode is not conducting, then there is no current. If there is no current, there is no drop in this resistance. So whatever voltage you have here, you have the same voltage here. And if this voltage or this voltage, or maybe because whatever you have here, the same voltage will be here. So you can say that if this voltage is greater than 0, then the diode will conduct. And you can see that in first half cycle, this voltage is greater than 0. It means in the first half cycle, diode has to conduct. So what will happen is in the first half cycle, the diode will start conduct. Diode will be sorted. Is it fine, guys? The diode will be sorted. Diode will be sorted. In the first half cycle, diode will be sorted and current will start flowing like this, and capacitor will keep on charging. Now, what will be the charging equation? We know that the initial voltage of the capacitor is 0. Let's assume that this circuit will keep on working. This 10 volt is applied here. This 10 volt is applied here, and this 10 volt is applicable for long time, for infinite time. Because this circuit doesn't know that at t equal to t by 2, at t equal to 2 millisecond, this voltage is going to change. The circuit doesn't know that. So it means this circuit will act as if this 10 volt is applicable for long time. So let's assume that this 10 volt is applicable for long time. Then what will happen is, then under steady state, this capacitor voltage will become 10. This circuit will keep on charging. I mean, it will keep on charging this capacitor, and under steady state, it will be 10 volt. Okay. Now, what is the time constant of this circuit? Time constant is RC, 500 into this. So it will be 5 into 10 is to power minus 3. Is it fine? So this will be the time constant. Now I can calculate the voltage equation. So VCT is equal to VC infinity plus VC0 minus VC infinity into 1 minus e to the power. If you write the direct equation, capacitor equation, then you'll get minus t by tau. So it will be 200t. Is it fine, guys? I mean, you don't need to write every step, no? You don't need to write every step. So this will be the charging equation. This is the charging equation of this capacitor voltage. Now, we know that this 10 volt is only for 2 milliseconds. So it means for 2 milliseconds, this capacitor will keep on charging. Now at 2 milliseconds, what is the voltage of this capacitor? You can put t equal to 2 milliseconds in this. So at t equal to 2 milliseconds, at t equal to t by 2, VCT will be equal to, tell me guys, it will be 10 into 1 minus e to the power minus 2 millisecond. T is 2 millisecond, no? So it will be 0.4. Is it fine, guys? 2 millisecond. 200 into 2 into 10 is 1 minus 3. Okay. So I think it will be 0.4. Now, can you calculate this value? What is the capacitor value? What is the capacitor voltage at 2 millisecond at the end of this half cycle? Tell me, guys, what is this value? Please calculate it. Please calculate this capacitor. How much voltage this capacitor will charge? Tell me by how much value this capacitor voltage will charge. It's 3.3. Okay, thank you. So it's 3.3 volt. Okay, 3.3 volt. Is it fine, guys? Tell me. 3.3 volt. Okay. As per Viswanathan, please, any other student, please confirm it. Is it 3.3? So this capacitor is charged to 3.3 within this half cycle, half period. Okay. Now after 2 milliseconds, what will happen? After 2 milliseconds, the circuit is changed. It means the supply is changed. Supply has the opposite polarity now, and the capacitor is charged with this polarity. Capacitor is charged with this polarity. So now the circuit will look like this. I have a resistor and a diode and the capacitor I have, and the capacitor is charged now at 3.3 volt as per Viswanathan. Banoth is saying same. Okay, so it means it's 3.3 and this resistor is R. Now what we did is we reverse this polarity. Now if you reverse this polarity, then what will happen is, then this diode will not conduct. This diode will become reverse bias. Why? Let's assume that this point is 0 volt. Let's assume that this point is at 0 volt. Okay. If this is at 0 volt, this will be at 10 volt. This will also be at 10 volt. This will be at 13.3 volt. Now you can see that this side is 13.3 and this side is 0. So current cannot flow in this direction. Current should flow from higher potential to the lower potential, no? But current cannot flow in this direction because diode is opposite. So now the diode will not conduct. So when this voltage is reversed, when this voltage is reversed, when this become -10, then the diode will stop conducting. It means current is not flowing. This diode is open circuit now. This diode is open circuit now. It means current is not flowing. During this interval, current is not flowing. If current is not flowing, then you can say that whatever the capacitor voltage is, that will remain constant. Why it will remain constant? Because no charge is entering, no charge is leaving. Current is zero. If current is zero, it means no charge is entering to the capacitor, no charge is leaving from the capacitor. So you can say that the capacitor voltage will remain constant at 3.3 volt. Okay. And we need to calculate at 3 millisecond. At this instant, we need to calculate this capacitor voltage. So the capacitor voltage will remain at 3.3 volt. Is it fine, guys? Have you understood it? Tell me, everyone. Have you understood this? So the answer is 3.3. Answer is 3.3 volt. Okay. Can I proceed? Tell me, everyone. Can I proceed to the next question? Let's move to the next question. Let's move to the next question, guys. So the next question is on your screen. And this question is, let me check the year also, no? In which year this question was asked. Okay. Yes. 2019. Okay. Now this question is 2019, 2 marks question. Please do it. Okay. Please do this question. It's very interesting question again. It's very interesting question. Tell me, guys, what is the answer? The RC circuit shown below has a variable resistance. Resistance value is this. Between 0 and t, this resistance changes with time. Okay. And this is the equation of the resistance, how it is changing. Okay. So at t equal to 0, you can see that this resistance is R0. And at t equal to capital T, it will become 0. At t equal to capital T, it will become 0. Is it fine? And this initial value is 1 ohm. This initial value is given as 1 ohm. Capacitance is given as 1 farad. Okay. We are also given that T equal time constant. Time constant is 3 into R0 into C. R0 is 1, C is also 1. So you can say that this capital T is the time constant, 3 times of time constant. This is 3 times of R0 into C. R0 is 1, C is also 1. So 1 second. There, this is 3 seconds. Is it fine? So this is 3 seconds. It is given in the question. This is 3 times of time constant. Okay. Which is 3 seconds. This time is 3 seconds. It is provided in the question. Okay. Now the source voltage is 1 volt. This is 1 volt. It is provided. It is 1 volt. If the time, if the current at the time, if the current at the time t equal to 0 is 1 ampere. Okay. How it is possible? Tell me, guys. He's saying Vs is 1 volt. That's correct. But he's saying that if the current at the time t equal to 0 is 1 ampere, it means if you close the switch, as soon as you close the switch, this will act like a short circuit. If initial voltage of the capacitor is 0, it will act like a short circuit, and 1 divided by 1, because initial value of this resistor is 1 now. So 1 divided by 1 is 1 ampere. Okay. So it's nothing new. If the current at the time t equal to 0 is 1 ampere, then the current in ampere at the time t by 2. Okay. T by 2 means at this time 3 by 2 second. I need to calculate the current value at t equal to 3 by 2 second. At t equal to 3 by 2 second, what current will flow? We need to calculate that. Calculate this. It's very simple question. Okay. R is changing with time. R is changing with time. C remains constant, and I need to calculate after closing the switch 3 by 2 second later, what will be the current value IT. Now, since R is time variable, so what should I do? Obviously, I need to write the Laplace equivalent of this. I need to take the Laplace of this circuit. No? I need to take Laplace. Is it fine, guys? So take the Laplace equivalent. Draw the Laplace equivalent of this diagram. Now this R is changing with time. Remember this point. So first of all, let's write the KVL in time domain. If I write the KVL in time domain, it will be VST minus IT into RT. Now this resistance is a time variable resistance, minus 1 by c integration it dt. Is it fine, guys? 0 to t is equal to 0. This is my KVL equation. This is my KVL equation. Is it fine? Have you understood it? Okay. Now, if I write this equation in Laplace domain, then how I'm going to do it? Take the Laplace of this. This is the equation in time domain. Okay, this is the equation in time domain. Now I want to write this equation in Laplace domain. Now how to write this equation in Laplace domain? It's simple. How to write it? Tell me, guys. VST. So the Laplace of VST is 1 by s minus it into RT. Now tell me, this it and this RT, both are the function of time. Both are the function of time. Is it fine? So now if I take the Laplace, then it's the product in time domain. If there is a product in time domain, then if it is the product in time domain, then will it be the, can I write it like this? IS into RS. IS into RS. Tell me, guys. Can I write like this? Can I write like this? Tell me, guys. Can I write like this? IS into RS. IS into RS. RS, you can take the Laplace of this circuit, no? Because many students think that RS will be equal to, if you take the Laplace of this, it will be R naught into 1 by S minus 1 by T S square. This is my RS. That is correct. That is correct. But the problem is, I think this is also not correct, because R naught into 1 minus T by 2 is valid only between 0 and T. Only between 0 and T. So what I need to do is, I think this is not correct. The Laplace transform of this RT, this is not correct. Why? Because this is correct if ut is there. If ut is there. But not only ut is there, actually this is multiplied with ut minus u of t minus t. Okay? ut minus u of t minus t. This is the function here. This factor multiply by this. Okay? Because this is valid only between 0 and t. That's why I have multiplied with it. So now the Laplace will not be this. Now how to calculate the Laplace transform of this function? Tell me, guys. How to calculate the Laplace transform of this function? Tell me, everyone, how to calculate the Laplace? This factor multiply by this. So what you can do is, you can take the Laplace here. Okay, this into this now. First this into this, and then first this into this. Okay, so this way you can calculate the Laplace transform. Yes, yes. Now the problem is, tell me, if you take the Laplace of it, that is IS, and the Laplace of RT, that is RS. Obviously, we need to calculate the Laplace transform, RS. We need to calculate the RS. Okay, RS I need to calculate. So now, if you take the Laplace transform on both sides, then you can't write it like this. Is it fine? You can't take the product of it. Because if in time domain, if they are multiplied, if two functions are multiplied in time domain, then they cannot be multiplied in Laplace domain also. Is it fine? Have you understood it? Tell me, guys. Have you understood this? So you can say that in time domain, if two functions are multiplied, then in Laplace domain, they must be convolved. Okay. There should be a convolution. So here I need to take the convolution. But if you take the convolution, then again you are under, okay, let's take it RS. Okay. IS convolution RS minus 1 by CS into IS. Is it fine, guys? I can write it like this. Tell me. Now you can't take IS common. You can't take IS common. Okay. Because if it is in multiplied situation, let's say IS into RS, then you can take IS common, and then whatever the factor is, you divide 1 by S by that factor, and you can calculate IS and then take the Laplace inverse. Okay. Here the problem is you can't take IS common out. Okay. And if you can't take IS common, then you can't find it. How to find this IS now? It's a challenging question now. Have you understood this problem? First of all, tell me guys, have you understood what is the problem in this question? In normal case, yes, in normal case, R is constant. This R is constant. If this R is constant, if it is not a function of time, then what you can say is, then you can say this R is constant, so you don't need to take convolution here. In normal situation, you have multiplication here, okay? You have multiplication with constant number R. Then in normal case, what you do is you take this IS on this side, okay? And you will have R plus 1 by CS, okay? And on this side, you have 1 by S, Laplace transform of this. 1 is 1 by S, okay? Take this in the denominator and take the Laplace inverse and you can calculate IT. In normal case, you do like this. But the problem in this question is, what is the problem guys? Tell me. What is the problem here? The problem here is you have to take IS convolution RS. Now you can't take IS common out. You can't take this IS common. So this is the problem now. Is it fine? Tell me guys. Is it fine? Have you understood this? Tell me. So now the problem, how to solve it? Tell me, is there any idea? Is there any idea how to solve this question? Let me tell you guys, this circuit is not LTI. This circuit is not linear time invariant. This circuit is not LTI. Because this circuit is time variant. This circuit is time variant. The elements are varying with time. This circuit is time variant. Okay. This is not LTI. Everything that you have studied is valid on LTI. This is non-LTI. Is it fine? Have you understood it? Tell me guys, this is non-LTI. Now how to solve it? Again, the problem remains the same. How to solve this question? Okay, let me try. Let's solve it in time domain only. You can't take it Laplace domain. Okay, you can't solve it in Laplace domain. Is it fine? Have you understood it? First of all, tell me. Have you understood this question? This is not an LTI situation. First of all, remember this point. Now, how to solve this? Okay, let's try this. I don't know whether I will be successful or not. I don't know that. But yes, you can apply the Laplace transform. There is no problem in Laplace transform. Now, what I'm going to do is, I am going to take the derivative on both sides. I need to calculate this IT. This is my equation, and now what I'm going to do is, I'm going to take the derivative on both sides. So if you take the derivative on both sides, then this will be dVst by dt minus RT into dit by dt minus IT into dRT by dt minus 1 by CIT is equal to 0. Is it fine guys? So I have taken the derivative on both sides. If you take the derivative on both sides, then also you have the problem. Now what is the problem now? You can calculate this value dVst by dt. You can calculate that because this voltage is applied after t equal to 0. So the voltage equation is like this. After 0 it is 1. So if you take the derivative, it will be delta t. Okay, it will be delta t RT into dit by dt, and then IT into dRT by dt. You can calculate dRT by dt from here. Okay, that's fine. Minus 1 by C into IT. I think it's difficult to solve. Now how to calculate? Tell me guys. No, you can't solve it using Laplace transform. No sir, you can't solve it using Laplace transform. Okay, you can't solve it because you can't find IT, because if you find some solution of this question now, if you find solution of this question, I think maximum teachers have done it like this now. They have taken the Laplace of RS and the Laplace of 1, they have replaced, whenever you look at the solution, what you will find is, you will find the Laplace of RT, that is RS, and the Laplace of capacitor is 1 by CS, okay? and here they replaced it with 1 by s. So what they have done is they have calculated is like this. Okay, they have calculated is like this. Is it fine, guys? So they have taken the Laplace of this, and the Laplace of capacity is 1 by cs, and the Laplace of this supply is 1 by s. So using this method, they have calculated this is. Okay. So now the problem is you can't do like this now, because it means what you are doing is, in this case, what is the problem in this case is, this method is applicable for LTI. This R is changing with time. Okay, R is changing with time. The problem is this. So this is a time variant situation. If this is the time variant situation, you can't make it like this. If you can make it like this, then obviously it is same. It is like this. Rs plus 1 by cs. You are doing like this. It means you are taking is common out of 1 by cs and rs. But we know that in Laplace domain, is is convolved with rs. Is is not multiplied with rs. So you got my point. Why it is wrong? Why it is wrong? Because you are not multiplying with rs. You are convolving actually. If it is convolved with rs, how can you take common? This is the main problem with the Laplace. And I think at maximum places you will find the solution like this. Now it's difficult to solve. It's difficult to solve. We have to solve it like this only. We have to solve this differential equation. Okay, we have to solve this differential equation. And I think it's very difficult to solve. Okay, let me see. Please check, is there any correction in the question or not? Is this question right? I want to check it. Wait a minute, let me see in which year this question was asked. So this question is asked in GATE 2019, EC 2019. Please check it. Please check GATE 2019. Check it, guys. Check the original question. I want to check this question. What is the original question? Please check it, guys. If you have GATE 2019 question paper, please check the original file. Let me see. I have the GATE 2019 original paper. Let me see whether they have provided this or not. Wait a minute, guys. Let me check it. This question was not there. It is not in GATE 2019. Wait. This question was not in 2019. From where this guy copied it? Is this question in 2019? Yes. It is in 2019. Yes. It is in 2019. Yes, it is in 2019, and within 0 to t, it is like this. Please check it, guys. Please check it. Please check it. Yes, 2019. I think it is in 2019. Yes, it is in 2019. Now, to solve it, obviously, you can't do it like Laplace transform. You can't do it Laplace transform. I think the question is same. Question is correct. Now, how to solve this question? Now, it's a challenge. Now, let's try to solve this question in a different approach. Because I can't solve this question using direct method, or you can say using Laplace transform. You can't do it because this network is not LTI. Now, what you need to do is, you need to write the KVL. If I write the KVL, then what you will get is, you'll get 1 minus RT into IT minus 1 by C integration IT dt. Is it fine, guys? This will be n equal to 0. This will be the equation I have. Okay, this will be the KVL equation I have. Now I need to solve this KVL equation. Here I need to put this RT. Now what is this RT? 0 is equal to 1 minus RT is R naught is 1 na? Let's take R naught as 1. R naught into 1 minus T by capital T is 3. Capital T is 3. So T by 3 into IT minus 1 by C integration IT dt. Is it fine now? Tell me guys. And this is equal to 0 again. Now the problem is, you will ask me, sir, this expression is valid between 0 and 3 na? So this equation is valid only between 0 and 3. That's correct. That's correct. Okay. This equation is valid only between 0 and 3. Have you understood it? What I have done is, I have written the KVL equation. So the KVL equation is 1 minus this drop, 1 minus this drop minus this drop equal to 0. So 1 minus IT into RT minus 1 by C integration IT dt is equal to 0. I have written like this. 1 minus, now RT. What is RT? RT is R naught into 1 minus T by T. Now R naught is 1. R naught is 1 minus 1 into 1 minus T by capital T. Capital T is 3. Okay. So I have written like this, into IT minus 1 by C IT dt. Now I have this equation. I need to calculate IT from this equation. But remember, this equation is valid only between 0 to 3, because this expression is valid between 0 and 3. Okay. Between 0 and 3. And we require between 0 and 3 only. Why? Because we need to calculate the current value at T by 2. We need to calculate the current at T by 2. It means at 3 by 2 second. So if this equation is valid between 0 and 3, then from this equation I can calculate the current equation, and then that current equation is valid between 0 and 3. In that equation I can put T equal to 3 by 2 and I can calculate this current IT. I have to solve this equation. Is it fine guys? I have to solve this equation. Now how to solve this equation? Now how to solve this? It's an integral differential equation. How to solve this equation? It's not an easy task. It's not an easy task. We need to solve it. How to solve it guys? Tell me. What you can do is, you can simplify this. 0 is equal to 1 minus IT plus T by 3 into IT minus integration IT dt. Is it fine guys? Equal to 0. Okay. This is the equation. Now I need to solve IT in this expression. I need to calculate IT and then put T equal to T by 2. It means 3 by 2. Okay. Now what is the solution of this guys? Tell me. This is the mathematics problem now. This is a mathematics problem now. Now how to solve it? How to calculate this IT? How to calculate this IT? Tell me how to calculate IT from here. Tell me guys. It's a maths problem now. 1 by C. C I have put 1. C value is 1 by 1 farad. Na? So if you try to solve this, let me check the solution. You will get, let me check the solution of this equation, this integral differential equation. So if you try to solve this question, you will get there is one more step you can do. That step is take derivative on both sides. If you take derivative on both sides, then what you will get is, wait a minute. This is a typical problem guys. This is a very good problem. Now if you take derivative on both sides, then you will get 0 is equal to derivative of this is delta t. Derivative of this is delta t. Because this is 1 ut, na? 1 ut. And the derivative is delta t. But actually we are not interested in that. We will make it 0. Why we will make it 0? I'll tell you. Okay? I'll tell you. So this is 0. This is 0 minus. So the derivative of 1 is 0 minus 1 minus t by 3 dit by dt. I have taken the derivative of it with respect to t. Okay? Minus of 1 minus t by 3 dit by dt. And then what I have to do is I have to take one more derivative, because I have taken the derivative of it, but now I have to take derivative of this term also, na? So it will be plus 1 by 3 it minus it is equal to 0. Is it fine, guys? Because if you take the derivative here, so it will be, you'll remain with it only. Okay, so you'll get this. At this point you're left with it only. Okay, here if you take the derivative, then it will be, first you take this term same and take the derivative of this term, dit by dt, minus of 1 minus t by 3 into dit by dt. And then what you can do is, you can take this term same, it same, and take the derivative of this term. So the derivative of this term is minus 1 by 3, and here one more minus is there, so it will be plus 1 by 3 into it, minus it is equal to 0. Now you have minus of 1 minus t by 3 into dit by dt minus 2 by 3 it is equal to 0. Is it fine, guys? Now I need to solve this equation. How to solve this equation now? How to solve this equation now? Is there any way? Tell me, guys, is there any way to solve this question? This is now it's it's a challenging problem. How to solve this, guys? Tell me. How to solve? Why I have taken this delta t as 0? Because the derivative of 1 is delta t. So I have not written delta t because I am not interested at t 0 plus, because I am interested at t by 2. At t by 2 that term will not be there. Okay, that's why I have not written that delta t down. Okay, so I have to solve this. I need to calculate it from here, and then I need to put t equal to t by 2 in that expression. Okay, so but now it's challenging for me. I don't know what is the solution of this equation. Now you need to calculate, guys. Tell me, what is the solution of this? Can you calculate for me? Tell me, guys. Tell me, can you calculate it for me? Because I think it's difficult for me. I don't know how to calculate this. Let me try. Variable separable form you can do, na? Because you can't take Laplace transform. This is not the simple equation. You have to apply mathematics. Using mathematics only you can solve this question. Okay, and I don't teach mathematics. I don't solve differential equation. So that's my you can say my boundary. So you have to solve it. So if you solve it, let me write the correct answer. Let me write the answer if you try to solve it. Because now you can solve it, na? You know how to solve the differential equation. Okay, you can apply the variable separable form, and using variable separable form you will get the answer that it is equal to c into 3 minus t square. You will get like this. Okay, c into 3 minus t square, and now you can calculate the c value also. So it will be 1 by 9 into 3 minus t square. C will be 1 by 9. C will be 1 by 9. So this will be the solution, guys. Okay, using the variable separable, Laplace transform you can't apply. This is not a LTI differential equation. This is not linear time invariant system. This is time variant system. You can see that the coefficient is time variant. That's why you can't apply Laplace transform here. Is it fine? Laplace transform method is not applicable here. So what you need to do is, you need to solve it by variable separable form. Okay, take this di by di term on this side and it on this side. What you can do is, let me take it further one step. So t minus 3 upon 3, you can write it like this: t minus 3 upon 3 di by dt is equal to 2 by 3 I. Is it fine? Now what you can do is, this 3 is cancelled, so you can say that di upon I is equal to dt upon t minus 3, and in the numerator you have 2. Okay, is it fine, guys? You can write it like this. Now what you can take is, you can solve it further. I don't know how to solve it. Now the variable separable, we have separated the variable. Now you can solve it, I think. Okay, yes, it took large time for me, because we have tried with Laplace, because we can't solve it Laplace. So I have told you why we can't solve it by Laplace. Then we tried it by simple KVL. We have applied simple KVL, and then I simplified this equation. I took the derivative so that this integral term can be replaced. Okay, so that's why I have taken the derivative of this. So I'll get this, and then what I did is, I separated the variable like this. Now on both sides, I have to integrate. Okay. Here the integration should be with respect to I. Here the integration should be with respect to t. Okay. Here the integration is with respect to t. Here the integration is with respect to I. Now we need to calculate I in terms of t. Is it fine, guys? This way you can calculate I. The I will be, I think this will be IT. Let me check. Let me check. I think this is the solution. I don't know whether this is correct or not. I think it's correct. T minus 3. Yes, I think it's correct. I think it's correct. So from here you can do it like this. If you take the integration, you'll get ln I, and here you'll get 2 ln t minus 3. Is it fine? Plus ln c. Plus ln c. You'll get like this. So take this 2 in. Take this 2 and it will become square. Eventually I know it, how to solve it. Anyway, so it will be ln I is equal to ln c into t minus 3 square. This ln will be removed. So I is equal to c into t minus 3 square. It should be t minus 3 square. T minus 3 square. Okay. So t minus 3 square. C into t minus 3 square. This is the expression for IT. Now you need to calculate this C value by using some initial condition. Initial condition is, we know that initially the current is 1 ampere at t equal to 0. This was IT came out to be C into t minus 3 square. Okay. At t equal to 0, this current is 1 ampere. So put it 1 here, put t equal to 0, you will get C equal to 1 by 9. So I have put C equal to 1 by 9. So this is the expression for IT. This is the expression for IT. Now this is a good question. Okay. This is very good question, guys. So IT came out to be 1 by 9 t minus 3 square. Now what you can do is, you can put this t value. T is 3 by 2. We need to calculate current at 3 by 2. So put 3 by 2 here. So 3 by 2 minus 3. That is again 3 by 2. Take the square of it. 9 by 4. 9 is cancelled. So IT came out to be 1 by 4. Is it fine? Fine, guys. 1 by 4 ampere is the correct answer. Okay. Now look how beautiful this question was. This question was very beautiful. You can't use Laplace transform. This circuit is time variant. Okay. This circuit was time variant. Okay. Yes, it took large time. But anyway, this question demands time. I have told you why you can't apply Laplace transform here. What's the problem with Laplace transform? Why can't you take Laplace of this RT and this C and Laplace of this 1 by S and then directly apply Laplace and directly solve it using Laplace? You can't do it. Okay. You have to solve this circuit by taking KVL. In time domain, you can solve it. So write the KVL equation, remove this integration sign by taking the derivative. So if I take the derivative on both sides, you'll get this. Okay, you'll get this. Simplify it, separate the variables, and then integrate on both sides, you'll get like this. Then calculate this constant value. Calculate this constant value, and then you'll get this. Okay. So I think this question was very good. Okay. So please look at this question. This was in 2019. Now let's come to the next question. So the next question is question number 7. This is not 6. This is actually 7. Anyway, in the circuit shown, if Vt is this, Vt is 2 sine 1000 t. 2 sine 1000 t. This is my Vt. R is 1 kilo ohm. It means R is 1000. This R is also 1000. 1000. And the C is 1 microfarad. Then the steady state current, this current I need to calculate. And the steady state, what will be this current? Okay. I need to calculate this current under steady state. Tell me guys, how to calculate that? How to calculate that? What is this steady state current? Tell me. Is there any idea? Is there any idea how to calculate this steady state current? Tell me guys, how to solve it? It's simple. What you can do is, you can make this C in delta. Okay. You can make this C in delta. R. Again, this is very good question. R, R, R. Or what you can do is, there is one more way. You can also convert this R in star. This R in star, there is no problem. Okay. You can convert this R in star, or you can convert this C in delta. Now tell me, if you convert this C in delta form, what will be this capacitance value? Can you tell me what is the capacitance value if you convert this C in delta form? What is this capacitance value? Can you tell me the capacitance value? This star capacitance is converted into delta capacitance. Tell me how to do it. What is the value of C now? Look, I have C in star and the value is C. I need to convert it in delta. What you can do is, you can write it like 1 by C. If you reciprocate this C, it will act like a resistance. Okay, it will act like a resistance. Now you can apply the resistance method, no problem. Now tell me, what is the equivalent resistance? This equivalent resistance. What is this resistance? They are acting like a resistance now. If they are acting like a resistance, the resistance between these 2 points is 1 by C plus 1 by C plus 1 by C into 1 by C divided by 1 by C. So you will get 3 by C. Is it fine? So the equivalent resistance here will be 3 by C. But now we are not interested in resistance. We are interested in capacitance. So this capacitance will become C by 3. Just revert it. Again revert it. Okay. So this is C by 3. This is a direct method. Okay. So this capacitance will be C by 3. But remember, in case of resistance, let's say you have resistances R, R, R. And if you convert them in delta, it will be 3R. It will be 3R. It means resistance are multiplied with 3. Remember. Okay. But in case of capacitance, you can see that the capacitance is C by 3. Capacitance is C by 3. Okay. What you can do is, first you write this C as 1 by C, 1 by C, 1 by C. Now it will act like a resistor. It will act like a resistor. So if you change this star resistance into delta resistance, it will be multiplied with 3. So these resistances will become 3 by C, but you don't want resistance, you want capacitance. So further invert it. If you further invert it, you will get the capacitance C by 3. Okay, so this capacitance is C by 3. Okay, this capacitance C by 3, this is C by 3. So we have converted it in delta. I hope you understood it. So whenever you convert this capacitance in delta, you'll get C by 3, C by 3, C by 3. Now this R and this C by 3 are in parallel. This R and this C by 3 in parallel. This R and C by 3 is parallel. So what you can do is, you can take the parallel combination. Let's take the parallel combination. Wait a minute. Wait a minute, guys. Let me erase this. Now we can take the parallel combination. So better take the parallel combination and try to solve it. Take the parallel combination, guys. If I take the parallel combination, then I'll have, on this side you have R in parallel with C. First let me write. Okay. Here also you have R in parallel with C. Here also you have R in parallel with C. Is it fine, guys? This is the circuit we have. This is the circuit we have. Is it fine? Now this R and C and this R and C, they are in parallel. I mean, this R and this C is in parallel, this R and this C is in parallel. But whatever the parallel is, that will be in series. Is it fine? Let's say the parallel came out to be Z. Let's call it Z. I don't want to calculate this parallel. Let's call it Z. So this will be Z also, this will be Z also. Now this Z and this Z will be 2Z. 2Z in parallel with Z. So Z into 2Z divide by 3Z. Fine. The Z is cancelled. So you will get 2 by 3Z. Is it fine, guys? Tell me. So you can say that the equivalent will be 2 by 3Z. This will be the equivalent impedance. This is the equivalent impedance of this. Now what is this Z value? The Z is the parallel of this R and C. R is 1000. R is 1000 in parallel with minus J by omega C. Omega is 1000. Omega is 1000. C is Tell me guys. C is 10 raised to power minus 6. Is it fine? Is it fine guys? But remember, this is R, this is not C, this is C by 3. So what I have to do is, I have to take 3 in the numerator. Minus J by omega C. C is C by 3 actually. So that 3 came in the numerator. So the reactance of this capacitance is this. Is it fine? And the resistance is 1000. I need to take the parallel of this. So it will be 1000 in parallel with minus J 3000. You can see that. Is it fine? That will be my Z. Now what is this? So it will be 1000 into minus J 3000 divided by 1000 minus J 3000. Is it fine guys? Okay. So take this 1000 common. So it will be minus J 3000 divided by 1 minus 3J. This is my Z value. Multiply it by 2 by 3. Is it fine? This is the equivalent impedance. We have calculated the equivalent impedance. So voltage divided by this impedance, you will get the current. Okay. Now how to calculate the current? Voltage is 2 angle 0. So what you can do is, you can take 2 angle 0 divided by this. Okay. 2 angle 0. So let's cancel it. This will be 1000. Please check the calculation guys. Please check the calculation. So it will be minus J 2000 divided by 1 minus J3. Please check the calculation. What I have done is, I have assumed that this is Z, this is Z, this is Z. Okay. I have converted this in delta. So in delta, this capacitor and this resistor will be in parallel. So I have done like this. Now Z and Z is 2Z, 2Z in and Z in parallel. So I have converted like 2 by 3Z. This is the equivalent impedance between these two terminals. So now what I did is, I calculated this Z value. How to calculate the Z value? This impedance value. Here you have two elements. Now, one is resistance. Resistance is 1000 ohm in parallel with the reactance of this capacitance. And the reactance is minus J by omega C by 3. Because this capacitance is C by 3 now. So 3 will come in the numerator. And the value of C is 10 raised to power minus 6. So minus J by omega. Omega is 1000 into C, 10 raised to power minus 3 by 3. Okay, so this will become 10 raised to power minus 3. This will go in the numerator, so it will become 3000. Okay, so 1000 in parallel with minus J 3000. Is it fine guys? Is it fine? So now you have this impedance. Even you don't need to calculate the parallel equivalent of this. No, you don't need to take the parallel equivalent. What you can do is, you don't need to take parallel. You don't need to take the parallel equivalent. Okay, you know that the capacitance, that the resistance value is 1000 and the capacitance value is this. If you take the parallel of these two, you'll get the Z. But now what we have is, we have 2 by 3 into Z. Okay, it means 2/3 of this impedance is the equivalent. So what you can do is, you know that if I take R and C in parallel, you will get Z. You will get Z. Just multiply every element with 2 by 3. This will be minus J 3000. This is 1000. This is 1000, right? This is 1000. If you take the parallel equivalent, you will get the Z. You will get the Z value. But we know that the impedance seen by the source is not Z. It is 2 by 3Z. So what you can do is, you multiply every element by 2 by 3. Okay, so if you multiply it by 2 by 3, it will be 2000 by 3 and it will be 2000 minus J 2000. Have you understood it? Tell me guys. Is it fine? So what I have done is, I have multiplied each impedance by 2 by 3. So now the impedance seen is this. This is the impedance seen. Okay, this is the impedance seen. Now tell me, if you know this voltage, that this voltage is how much voltage? We have 2 angle 0. Then what will be the current? Well, the current has two components. One is in phase component and one is 90-degree leading component. Now tell me, what is in phase component? In phase component is 2 angle 0 divided by this impedance. Okay, so you will get current in milliampere. In this branch, you have 3 milliampere current. 2 divided by 2 angle 0 divide by 2000 into 3. Okay, so this is cancelled with 1000. So you can say that this is 3 milliampere, and this will be in phase component, in phase with this. So 3 milliampere will be in phase. You can see that this 3 milliampere is in phase with this. So answer is Calcutta only. You don't need to check other options. Okay, you don't need to check this option, and this, because in here you have 1, here you have 2, here you have 1. So, but we know that in this in phase component current, in this in phase component of current, the magnitude should be 3. Voltage divided by this resistance will be the in phase component of the current, na? Because there will be 2 components of current. One is leading component, 90 degree leading, and one is this component. Is it fine? So this in phase component of current is 3 milliampere, and 3 came out to be in this C option only. Okay, so I hope C is correct answer. You don't need to solve it further. Now you don't need to take the parallel equivalent either. Why should I take the parallel? Why should I waste the time? Okay, you can directly do it like this. I hope you understood it. Now let's proceed with the next question. So the next question on your screen is, consider 2-port resistive network shown in the figure when an excitation of 5 volt is applied at port 1. So we have applied 5 volt at this, and the port 2 is shorted. The current through the short circuit port 2 is measured to be 1 ampere. This current is 1 ampere. Okay, fine. Now if the excitation of 5 volt is applied at port 2 and this is shorted, what is the current through the short circuit? Okay, we need to calculate this current. So you can apply reciprocity here. Tell me, if you apply reciprocity, if you take this 5 on this side, this 1 will go on this side. Okay, so this will be 1 ampere. Directly you can say that. Is it fine? So this is a reciprocity based question. Let's move to the next question. Now you can see this question. Tell me guys, the current I in the given network is, in this given network we need to calculate this current I. What is this current I? Tell me, how to calculate this current I? Tell me guys, how to calculate this current I? It's simple. What you can do is, you can assume that this is 0. If you assume this point to be 0, then the upper voltage will be 120 angle minus 90, fine. And the lower voltage will be 120 angle minus 30. Is it correct? The upper voltage will be minus to plus, it will be added. So 120 angle minus 90, and this will be 120 angle minus 30. Is it fine guys? So we have found this point voltage and this point voltage, and this point is 0. Is it fine? Now what you can do is, you can calculate this current and you can calculate this current, and you can apply KCL at this point. Is it fine? Now if you apply the KCL, what is this current? This current is 120 angle minus 90 divided by Z. Tell me, is it correct? 120 minus 90 minus 0 divided by Z is this current. What about this current? This current is 120 angle minus 30, 120 angle minus 30 minus 0 divided by Z. Okay, this is this current. So entering current, there is one more entering current, I. This is entering current, this is also entering current, and I is also entering current. There is no leaving current at this node. This is entering, this is also entering, this is also entering. So leaving current is 0. So total sum must be equal to 0. From here you can calculate I as minus O. Is it fine guys? Divided by Z plus 120 angle minus 30 divided by Z. Take this Z common. Okay. So I is equal to, if I take minus 1 by Z common, Z is 80 minus J35. 80 minus J35, and here you have 120 angle minus 90 plus 120 angle minus 30. Now you can solve it. You can solve it using calculator or whatever. Okay, and check the answer, which option is correct. Tell me guys, which option is correct? I think now it's easy peasy. You can solve for this I. Okay, so you can calculate the answer. You can check which option is correct. Let me do it for you. Let me do it for you. So if you calculate this, in the numerator you have 120 at an angle of minus 90 plus 120 at an angle of minus 30 divided by 80 minus 30 iota. So this came out to be, and here you have one more negative sign. Okay, so the answer came out to be 2.43 angle 140. 2.43. It means approximately C answer is correct because there is a problem in the decimal. Okay, is it fine, guys? You can see that the approximate answer is this. Okay, you can solve it from here. It should be 35. Wait a minute, it should be 35. Okay, so I think I did mistake in calculation because my answer is 140 and 3 point something. So 2.43 something, but actually it is 2.38 because I have taken 30 here. You have to take 35, it is given 35. Okay, so please calculate it. I think option C is correct. Only the mathematical calculation is required. Sir, in exam, how to proceed with this calculation? Yes, it's a difficult calculation in exam. So in exam, what you can do is you can break it in component. Okay, let's take it -1 divided by 80 minus J35, and here you take it minus J120, and here you break it. How to break it? Take cos 30. Cos 30 is root 3 by 2. So it will be 60 root 3 minus J sine minus J 60. Okay. So I have broken it in real part and imaginary part. Now combine the real part. Since this does not have real part, so real part is 60 root 3. So you can say that minus of 60 root 3, and the imaginary part is minus J180 divided by 80 minus J35. Okay. Now how to do it? What you can do is you can look at the options. In option, angle is different in each option. Magnitude is same in 3 options, but angle is different. So better calculate the angle of the numerator and the angle of the denominator, and take the difference, and according to that you can get the answer. Okay, I mean you have to be attentive. Okay, you have to check whether I should check the magnitude of this quantity or angle. Let's say you have calculated the magnitude of numerator and denominator and you have divided it. You will get 2.38. But 2.38 is in 3 options. So you can't calculate the right answer. No? You can't check the right answer. So better you calculate the angle of the upper quantity and the lower quantity. Okay. Take the angle of entire quantity and then check which option is correct. Let me tell you one more thing. This negative sign represents 180 degree angle. Due to this negative sign, you have 180 degree angle. Now look at this quantity. This quantity has, this is in 4th quadrant, it has some negative angle. How much negative angle it has? Let's say theta 1. Theta 1 is less than 90, that's for sure. Okay, and this quantity will also have negative angle, but it will become positive. It will become positive. This is also less than 90, this is also less than 90. Okay, so the rough idea says that this answer should be greater than 90. Okay, because this is 180 minus this quantity is less than 90 plus this quantity is less than 90. Let's say this is 80, this is 60, whatever you take. Okay, so this answer came out to be greater than 90. Greater than 90 is this. Okay, 143. Moreover, this will be 4. Okay, this is my IT. The value of inductor, I need to calculate the value of L. Okay, how to calculate the value of L? Tell me, guys, how to calculate the value of L? Okay, look, we know that this is the steady state current and this is the steady state voltage. First of all, look at this magnitude. The magnitude of this will be equal to 200 divided by root of R square plus omega L square. Is it fine? Now, do you know the value of R? No, sir, you don't know the value of R. Okay, you don't know the value of R. Fine. So you don't know the value of R, you don't know the value of L. We need to calculate the value of L. Now look, this current is lagging by 45 degree. If this current is lagging by 45 degree, it means R, this impedance and this impedance are same. It means R must be equal to omega L. Okay, this impedance would be R plus j omega L. Na? If they have the same value, then the impedance angle of this impedance is 45 degree. It means the current will lag by 45 degrees. Is it fine? So you can say that R and omega have the same value. So what you can do is you can put it omega L equal to R only. So 10 is equal to 200 divided by root of R square plus R square. R square plus R square. Is it fine? So take this R common. So you will get R is equal to 200 divided by 10 root 2. Is it fine, guys? This is cancelled. So I'll get 10 root 2. R is equal to 10 root 2. And we know that R is equal to omega L. Omega is given as 5. So L is equal to 2 root 2. Is it fine? I have divided with this omega L. So you'll get 2 here. So 2 root 2. L is 2 root 2. Is it fine, guys? Okay. Kitretsu, sir, I learned power electronics from you without mugging any formula. I am able to solve PYQ, but time taken by me is almost double what GATE exam provided. What should I do? Practice. Do the practice. Because if you watch my sessions on power electronics, you will see that I don't use any formula, but I do make. If you have good practice now, then you can jump to the question directly. Because then you will not take much time in thinking, because your practice is very high. Okay. So if you can do good practice, then you can say that then you don't need to cram any formula and you can solve the question easily within the bounded time. Okay. Yes, obviously you'll take some extra time. Let's say somebody is solving the same question in like 30 seconds, then you may take 40-50 seconds or maybe 1 minute. Okay, it's okay, no problem. But remember, you don't need to remember any formula. Okay, I mean, you need to be careful about that. So it's a good thing. You don't need to remember any formula. So that's a good idea. But I mean, there is a trade-off now. Okay, now you have to devote some extra time. But anyway, it's enough. I mean, it's okay if you devote some extra time for that. So it's not a bad idea. I mean, you can do the practice and you can improve your speed. Okay, so please do some more practice. Your speed will be improved. Okay, so L is equal to 2 root 2. So from this question we calculate L. Now in this question, actually what they have done is they have put 2 questions. Okay, now look, this question is different and this question is different. First, let's try to solve this question. What is this question? In the given circuit, the two-port network has the impedance Z parameter of this network is given. The value of ZL for which maximum power is transferred to the load. We need to calculate the ZL value such that the maximum power transfer. So I need to calculate Z Thevenin of this network. Now how to calculate the Z Thevenin of this network? How to calculate ZTH of this network? To calculate ZTH, what you need to do is you remove this ZL, put a current source here and calculate the voltage across it. Okay, and deactivate this source. Is it fine? So if I deactivate this source, and if I put a current source here, let's say current source is of 1 ampere, remove this ZL now, put a current source here, deactivate this and try to calculate this voltage. This voltage divided by 1, you'll get the ZTH. Okay, now how to calculate this? First of all, you need to write this equation, Z parameter equation. So V1 is equal to, write this equation, don't look at the outer connection. V1 is equal to 40I1 plus 60I2 and V2 is equal to 60I1 plus 120I2. Okay, now this is the Z parameter equation. Now look at the external connection. In external connection, I2 is 1. So put I2 equal to 1. So what you can do is, you can erase this I2 and put I2 equal to 1. So I have put I2 equal to 1. Now this is the equation. Now look, what is V1? If current I1 is coming like this, so this will be 10I1. And it is sorted here. This 120 is not there. It is sorted. So V1 is minus 10I1. So what you can do is you can replace V1 with minus 10I1. You can replace V1 with minus 10I1. Is it fine, guys? You can replace V1 with minus 10I1. Okay. Now what you can see is we need to calculate this V2. V2 divided by 1 is the RTH. If you know the process now. Okay. So how to calculate this V2? First you calculate this I1 now. So from here you can see that minus 50I1 is equal to 60. So from here I1 is equal to minus of 6 by 5. I1 is minus 6 by 5. Is it fine, guys? And put I1 here. So V2 is equal to 120 plus 60 into I2. 16 to I1. I1 is minus 6 by 5. Okay, this is cancelled with 12. Okay, so V2 is 120 minus 72. Is it fine? And this will be 48. You can see that. Is it fine, guys? So V2 came out to be 48. 48 divided by 1 is RTH. So RTH came out to be 48 ohm. So you can see that ZL must be equal to 48 ohm. Is it fine? ZL must be 48 ohm. Okay, so that the maximum power can be transferred. So this question was again easy. Now the next question is the Thevenin voltage for this network. I need to calculate the Thevenin voltage. For this network, I need to calculate VTH. Now how to calculate VTH? How to calculate VTH for this network? It's simple. What you can do is, there are so many junctions, na? So let's minimize the junction. How to minimize the junctions? What you can do is, you can make it voltage source and you can make it voltage source also. So if you make the voltage source, this will be 2 ohm, this will be 2 ohm and this will be 4 volt. Fine. This is 2 ohm in series with 4 volt. On this side, you have 2 ohm, here and 2 volt, and here 1 ohm and 1 volt. Okay, I have converted in voltage source. Is it fine, guys? And here you have 4 ohm. Okay, 4 ohm. We need to calculate this VTH. I think it's easy now. Now how to calculate this? You need to calculate this voltage only. Whatever this voltage is, the same voltage will be available here. Okay. Now how to calculate this voltage? You can apply direct nodal. Okay, you can apply the nodal equation. Let's call it VA. Now tell me the coefficient of VA will be, what is the coefficient of VA? It's 1 by 2 plus 1 by 3. If you know how to write it directly, your speed will be increased. 1 by 2 plus 1 by 3 is equal to entering current. So entering current is 4 by 2. 4 by 2 is 2 ampere. 2 ampere via this, and 1 plus 2. 1 plus 2 is 3 volt. So 3 divided by 3, 1 ampere from this side. Okay, 1 ampere from this side. Now VA will be equal to 3 into 6 divided by 5. Okay, so it will be 18 by 5. 18 by 5 is 3 point something. Answer is 3.6. Okay, is it fine, guys? So this way you can solve it. I mean, this was simple question. Thevenin voltage I need to calculate. In this circuit we need to calculate Thevenin voltage. So this is a separate question and this is a separate question. Here you need to calculate ZTH. So to calculate ZTH, I remove this ZL, I applied a 1 ampere current source, I deactivate this source and I calculate this V2. So how to calculate this V2? You first write this internal equation, replace I2 with 1 ampere, replace V1 with minus 10 I1, okay? Because this is sorted, so this voltage is 10 I1, it is opposite to this V1, okay? So if you write this KVL, V1 is minus 10 I1. So V1 came out to be minus 10 I1, okay? So you replaced V1 as minus 10 I1 and I2 as 1 and then calculated this V2. Whatever this V2 is, V2 divided by 1 is RTH, okay? And RTH is ZL. This ZL must be equal to RTH, okay? So this way you can solve it. So there are 2 questions on this screen. Let's come to the next question. Question number 11. What is this question 11? The circuit in the figure contain a current source. We have a current source, okay? Contain a current source deriving a load having an inductor and a resistor in series. So we have an inductor and resistor in series with a shunt capacitor across the load. The emitter is assumed to have 0 resistance, okay? This is ideal. The switch is closed at t equal to 0, fine. Initially, when the switch is open, the capacitor is just discharged and emitter reads 0 ampere, okay? It means it was discharged, there was no current. Initially the switch was open, so there was no current. After the switch is closed, the emitter reading keeps fluctuating for some time till it settles to the final steady value. The maximum emitter reading that one will observe after the switching is closed, okay? After the switching is closed, it means after the switch is closed, what is the maximum current that this emitter will observe? We need to calculate that, okay? So again, this is a very good question. Now how to solve it? How to solve it? Because this is a current source, remember, this is not a voltage source. This is a current source. Now if it is a current source, then this emitter reading, if you want to check the maximum value of this emitter reading, then what you need to do is, you need to take the Laplace. Better you go with the Laplace transform, okay? Because I think the current will oscillate like this. I think the current will oscillate like this. We need to calculate this maximum value of the current, okay? This is the steady state value and we need to calculate this maximum value of the current. It means he's not asking the steady state value, because steady state value is not the maximum value, okay? Steady state value is not the maximum value. Is it fine, guys? Have you understood it? Steady state value is not the maximum value. Maximum value will come before that. The current will fluctuate like this, okay? Is it fine? First of all, tell me, guys, is it fine? Now I need to calculate this maximum value. How to calculate it? So first, what you need to do is, using Laplace transform, try to calculate this value. Try to divide this current. So in Laplace domain, it is 1 by S. This will be 1 by CS. 1 by CS. Let me write it somewhere. Let me see the free. Okay, let me erase this, and here I am going to. Okay, let me erase this. Now you have this current as 1 by CS, 1 by S, and this capacitor as 1 by CS. I'll put the value after calculation. And here you have LS and R. Is it fine? We'll put it later. I need to calculate this current. So this current will be, you can apply current division. So if I apply current division, then it is 1 by S into this impedance, that is 1 by CS, divided by the sum of these three, 1 by CS plus LS plus R. Is it fine? So now it will be 1 by S into 1 divided by LCS square plus RCS plus 1. Okay guys, this is my current equation. This is the current which will flow in this direction. Is it fine, guys? You can see that 1 by S into, if you simplify it, you'll get LCS square plus RCS plus 1. Now take this LC common. So it is 1 by S into 1 by LC divided by S square plus R by LS plus 1 by LC. Okay. Now this is the current which is going to flow in this direction. This is the current which is going to flow in this direction. Is it fine? Is it fine? Now remember, this is a second order system and this is the input. Input multiplied with this system is the output. This is I naught S. Okay, this is I naught S. Is it fine, guys? This is the system transfer function. It will act like a transfer function. It will act like an input. Input is 1 by S. UT, step input is there, and this is the second order system, and this is my output current. So you can see that the output is, since the system is underdamped, how can you say that? How can you say that this system is underdamped? Okay, you can put the RL value and LC value, and you can see it yourself. Okay, this is an underdamped system. If this is the underdamped system, then the output current will be like this. It will be like this. Is it fine, guys? Is it fine? Is it fine? It will be like this. Now, what is this maximum value? How to calculate this maximum value? Tell me, guys. At what time this maximum value you will get? And what is this maximum current? So this maximum value is this steady state value. What is this steady state value? The steady state gain is 1 and the steady state input is 1 also. So the steady state output is 1. So the current will settle at 1 ampere. That's correct. Current will settle at 1 ampere. Okay. This current will settle at 1 ampere plus this overdamped plus MP. Okay. So 1 plus MP. Okay. 1 plus MP is the maximum current. Is it correct, guys? 1 plus MP. 1 is this steady state current which will, because you can see that under steady state this capacitor will be open circuit. Under steady state this capacitor will be open circuit. Okay. And this inductor will be short circuit. So entire current will flow through this. So under steady state this current is 1 ampere. That's correct. 1 ampere. But we don't want the steady state current value. We want this peak value, maximum current. So steady state value plus this overshoot. Overshoot is MP. Now how to calculate this MP? Tell me, guys. How to calculate this MP? MP is very easy. 1 plus MP is e to the power minus zeta pi divided by root of 1 minus zeta square. Is it correct, guys? Is it correct? Tell me, everyone. Is it correct? So this is the peak value of the current. Now, how to calculate zeta? We need to calculate zeta. Tell me, this is a control system problem now. We need to calculate zeta. How to calculate zeta? Look, the denominator. Look, the denominator. Let me write the denominator first. So denominator is S square plus R by L. R is 5000, L is 10 millihenry. So 5000 divided by 10 into 10 to the power minus 3. So R by L will be equal to, if you simplify it, it will be 500 into 10 to the power 3. 500 into 10 to the power 3. Is it fine, guys? Plus 1 by LC. What is 1 by LC? 1 by LC. 1 by L. L is 10 into 10 to the power minus 3. And C is 100 into 10 to the power minus 12. Okay. 100 into 10 to the power minus 12. So the value will be 1000. So 10 to the power minus 12 will be there. No? So in the numerator, it will be 10 to the power plus 12. Is it fine? Wait a minute. Oh, why it's stuck? Uh-oh. Okay. So you can say that plus 10 to the power 12 here. Okay. 1 by LC. 1 by LC you need to calculate now. So L is 10 into 10 to the power minus 3 and C is 100 into 10 to the power minus 12. So 100 into 10 is 1000. This will be cancelled with 10 to the power minus 3. So 10 to the power 12 will be there. Okay. So you have this. So now the denominator is this. We need to calculate zeta. How to calculate zeta? We know that this is omega n square. So omega n came out to be 10 to the power 6. And we know that this factor is 2 zeta omega n. So 2 zeta omega n is 500 into 10 to the power 3. Okay, now you calculate zeta from here. So zeta will be equal to, what is the zeta? Zeta came out to be 500 into 10 to the power 3 divided by 2 omega n. 2 into 10 to the power 6. Is it fine, guys? Okay, so this will be 0.25. Zeta came out to be 0.25. This is under damped system. Okay, now you put this zeta here. Okay, and you can calculate the peak value of the current. So the peak value of the current will be, can you calculate for me? 1 plus e to the power minus zeta. Zeta is 1 by 4. So pi by 4 divided by root of 1 minus zeta square, 1 by 16. Is it fine, guys? Please calculate this. Zeta is 0.25. Do it, guys. This is the peak current. Okay, this is the peak current. In which year? And this is EC branch. This question is for EC branch. And let me tell you the year also. In which year this question was asked? I think for 2020. This was asked in 2020. I don't know. But let me check. Let me check in which year this question was asked. Because I have the original file. Na? So I can check it. Using the original file, I can check it. Okay, so this question was asked in 2021. This is for 2021, guys. Okay. Yeah, tell me. So what is the peak value of the current? Now you can calculate the peak value like this. 1 is the steady state current plus this MP. MP is e to the power minus zeta pi divided by 1 minus zeta square. Okay. Now you need to calculate zeta. How to calculate zeta? Using the transfer function, the denominator of the transfer function. S square plus R by LS plus 1 by LC. So 1 by LC is this. R by L is 5000 divided by 10 millihenry. Okay. So 5000 upon 10 is this 0 is cancelled. 500 into 10 to the power 3. This is R by L. This is 10 to the power 12. So you calculated that zeta from here came out to be 0.25. So put zeta here 0.25. 0.25 means 1 by 4. So 1 minus pi by 4 divided by root of 1 minus 1 by 4 square. Okay. So the peak value of the current is 1.44. Thank you, UG. So peak value of the current is 1.44. Is it correct, guys? Tell me. Have you understood it? This was again a very good question. Very nice question. Okay. And I hope that you guys have solved it. So tell me, guys, have you understood this question? Say yes or no. Say yes or no. Can I proceed with the next question? So this is a mixture of control system and network theory. Okay. This is again a very good question. Now let's proceed with the next question. This is the question, guys. Now in this question, an asymmetrical periodic pulse train V in of 10 volt amplitude with on time 1 millisecond and off time 1 microsecond. Okay. So this is a wave here, and this wave is like this. The on time is 1 millisecond. The on time is 1 millisecond. For 1 millisecond, this is on. And then for 1 microsecond, it is off. And then it is on again. Okay. So you have the wave like this. This is 1 millisecond. Up to this time, you have 1 millisecond. This is 1 microsecond. So for 1 microsecond, it is off. And 1 millisecond, it is on. And this level is 10 volt. Okay. The diode D1 is ideal. The difference between the maximum voltage and the minimum voltage of the output voltage. Okay. We need to calculate the difference between the maximum voltage and the minimum voltage of the output voltage waveform. Whatever the output voltage waveform is, we need to check what is the difference of, ripple we need to check. Okay. What is the difference of output voltage and the input voltage? Okay. We need to check it. Now, how to check it? How to check the difference between minimum and the maximum voltage? Now, to see that, what you can do is, let's assume that initially, okay, let's assume that the wave is like this. Okay. This is my wave. This is the input signal. Now, if this is the wave, in the first half cycle, in the first on period, okay, during the on period, you can see that as soon as you switch on this supply, what will happen is, this capacitor will charge to 10 volt. Abruptly it will charge to 10 volt. Okay, via this path. As soon as you switch on this supply, since this is 10 volt na, and this is 0, okay, so as soon as you switch on this 10 volt, what will happen is, impulsive current will flow in this path and this will charge to 10 volt, and then it will further stop conduction. Now current cannot flow via this or via this, okay, because capacitor is charged at 10 volt. So it is 10 volt. So you can say that if you want to plot this, the current shape, the current will be impulsive here. As soon as you switch on this, at the same instant, because this is 10, this is 0. So the diode will be on, and eventually it will become 10. Okay. Within 0 time, it will become 10. This capacitor is 10 now. Rather, we plot the capacitor voltage, VCT. We can plot the capacitor voltage. Don't plot the current. Plot the capacitor voltage. So the capacitor voltage is 10 now. Okay. And it will remain 10 up to this T on time. It will remain 10. Okay. It will remain 10 because this path will not work now. This path will also not work now because the loop voltage is 0. Because this is 10, this is 10. So the total loop voltage is 0. Okay. Now what will happen is, if this is 0, 0 means it is sorted. If it is sorted, then what will happen is, this capacitor will discharge. Okay. Discharge via this path. So you can say that now this 10 volt will discharge exponentially up to this level. I don't know this value. I don't know this. What is this value? So obviously this value will decrease. This 10 will not be 10. Let's say it is less than 10. Let's say it's VC min. This is VC. Now it is VC. So via this resistor it will discharge because this voltage is 0 now. It is sorted. You can deactivate this source. If this source is deactivated, this will discharge. This will discharge. So it will decay like this. Now at this instant, what happens is, again this is 10. If it is 10 and it is less than 10, again the diode will be forward bias. Okay. This is 10, this is let's say 8 volt. So if this is 10, this is 8, then this voltage will be higher than this lower voltage. Diode will be sorted and eventually this will become 10. Eventually it will become 10. Okay. And then it will remain at 10. It will remain at 10. Is it fine, guys? This is my capacitor voltage. This is my capacitor voltage. Have you understood it? This is my capacitor voltage. Now, if this is the capacitor voltage, now what is this value? I need to calculate this value. Once you get this value, you can easily plot the output voltage wave shape. You can easily plot the output voltage. I don't know how many of you understood how I have plotted this. You want me to repeat this again? Tell me, guys. You want me to repeat this again? Tell me, everyone. You want me to repeat this wave shape again? How this happened? Tell me, you want me to repeat this again? Tell me. Okay, let me tell you. Let me tell you guys. Look, initially it is not charged. This capacitor is not charged. Okay. And what you did is, initially this capacitor was not charged. This capacitor was uncharged. Okay. Now this is 0 volt. And let's say this is grounded. As soon as this voltage is 10, obviously either this circuit will work or this circuit will work. Now which circuit will work? If this circuit is working, this will have some voltage across it, and that will make the diode conduct. That will make the diode short. It means resistor cannot conduct. I mean the current cannot flow via resistor. The diode has to turn on. Is it fine? Okay, the diode has to turn on. So you can say that if this is 10 volt, diode will be sorted. Okay, the diode will be sorted. If the diode is sorted, you can say that this 10 volt will come directly across it. It is sorted. So this 10 volt will come in parallel with this capacitor. So it means the capacitor will charge to 10 volt abruptly. Okay, so capacitor will charge to 10 volt abruptly. Now this is 10 volt. Within 0 second, this will be 10 volt. Okay. Now the capacitor is 10 volt. Now tell me, how much current will flow via this path or via this path? No current. Because if you apply the KVL in this loop, this is 10 minus 10. You have 0 voltage here, 0 here. So there is no current here. Similarly, no current via this path. So now the current will not flow. If the current is not flowing, then you can say that the capacitor will remain at 10 volt. Okay. Capacitor will remain at 10 volt now. Capacitor will remain at 10 volt. Okay. So this is 10 volt, this will remain 10 volt. So capacitor will remain 10 volt. Now, after 1 millisecond, this is sorted. Okay. So this source is sorted now. If you sort this source, this 10 volt will discharge via resistor because it cannot discharge via diode. Diode will not allow the reverse direction current. So this capacitor will discharge via resistor. So exponentially, the capacitor will decay for 1 microsecond. Okay, it will decay for 1 microsecond. The voltage will decrease. Let's say this voltage will decrease to, I don't know, we can calculate this value. Now let's try to calculate how much voltage will decrease. Initial voltage is 10. Initial voltage is 10. Tell me guys. Initial voltage is 10. What is the steady state value? If this circuit will work for steady state, the steady state voltage will become 0 and the time constant is C into R. So that will be 20 into 10 to the power minus 9 into this R. R is 500 into 10 to the power 3. Is it fine? So if you can calculate this value, this is 5,000 into, so 10,000 into 10 to the power minus 9 into 10 to the power 3. Is it fine guys? So it will be 10 to the power minus 2. Okay, you can check it. 10 to the power 4 here, 10 to the power 3 here, 10 to the power 7 into 10 to the power minus 9 is 10 to the power minus 2. So you can say that the time constant is 10 to the power minus 2. Fine. So now you can calculate the capacitor voltage equation. So the capacitor voltage equation is 10 into e to the power minus 100t. This will be the capacitor voltage equation. So the capacitor will decay. Capacitor will decay. Now if you put t equal to 1 microsecond, because I want to look at the capacitor voltage after 1 microsecond, na? Because the off time is 1 microsecond only. So after 1 microsecond, this capacitor voltage will be 10 e to the power minus 100 into 10 to the power minus 6. So it will be 10 e to the power minus 10 to the power minus 4. Can you calculate this value? Tell me guys, what is this value? What is this value? Can you calculate this value? 10 e to the power minus 10 to the power minus 4. Okay, if you can check this value, let me do it for you. 10 e to the power minus 10 to the power minus 4, 9.9990. 90. Okay, this value. It means the capacitor will discharge to very small value. It will discharge to very small value. Is it fine? It will discharge to very small value in 1 microsecond. Now what will happen after that? Have I done it correctly? Tell me guys. I think I have done correctly. Everything is fine. 20 nano. Okay. Okay. I think everything is fine. Okay. Every calculation is correct. Now, so it will decay to 9.99990. Okay. Now, after this off period, then again it will on. It will on for 1 millisecond again. If it is on, again, it will abruptly charge via this diode to 10 volt. Okay. It abruptly 10 volt and then decay like this, and then again charge like that. Okay. So this is the capacitor voltage. But we want output voltage. We don't want capacitor voltage. We want output voltage. Now how to plot output voltage? Output voltage is this supply voltage Vs minus this capacitor voltage. You'll get the output voltage. This voltage minus this capacitor voltage, you'll get the output voltage. Okay. So this is my supply voltage minus this capacitor voltage. You will get the output voltage. Now tell me, if you take the difference, the output voltage wave shape will be during first millisecond. This is 10, capacitor is also 10. Take the difference, output is 0 volt. Now during this interval, this is 0 and capacitor is this. So if I take the difference, it will be like this. Is it fine, guys? And then again 0. Then again 0. Okay. So this is my output voltage wave shape. Now tell me, the question is the difference between the maximum voltage and the minimum voltage of output voltage. So the minimum output voltage is 0 and the minimum output voltage is minus 10 and the maximum output voltage is 0. Is it fine, guys? Minimum output voltage is minus 10 and the maximum output voltage is 0. Okay. So you can say that the difference is 10 volt. So the difference is 10 volt. Is it fine? Difference is 10 volt. We need to plot the output voltage. Output voltage is this in source voltage minus this capacitor voltage. You will get the output voltage. If you apply the KVL in this loop, na? Okay. So VST minus VCT equal to V naught T. Okay. So VST is this, VCT is this. VST minus VCT, you will get V naught T. So I took the difference. This minus this. So this is 10, this is 10. If you take the difference, it will get 0. Here you have 0 and here you have the shape like this. So if you take the difference, it will be negative. Is it fine? Minus 10 to minus 9.99 and then again 0. This is the maximum negative and this is the, you can say this is the minimum voltage at the output and this is the maximum voltage at the output. Maximum is 0, minimum is minus 10. So the difference is 10 volt. Okay. So the answer came out to be 10. Is it fine? Let's come to the next question. Question number 13. Now tell me what is the answer of this question number 13. In the circuit shown in the figure, the switch is closed at time t equal to 0. At t equal to 0, we are closing the switch. While the capacitor is initially charged to minus 5 volt. Okay. So this capacitor was initially charged to minus 5 volt. Okay. VC0 is minus 5. Opposite polarity it is charged. The time after which the capacitor voltage becomes 0. Okay. It is asking after what time the capacitor voltage will become 0. Now what you need to do is you need to calculate RTH and VTH for this circuit. Okay. If somehow we can calculate this RTH and VTH, then it will be easy for us. And you have this capacitor voltage. The initial voltage of the capacitor is, this is VCT. Initial voltage of this capacitor is minus 5. Now what is the steady state voltage? Steady state voltage is VTH. If I close this switch, under steady state, this capacitor will charge to this VTH value. Is it fine? And what is the time constant? Time constant is RTH into C. RTH into C. Now you can write the capacitor voltage equation. Capacitor voltage equation is VC infinity plus VC0 minus VC infinity into e to the power minus t by tau. Is it fine, guys? This is my VCT. This is my capacitor voltage equation. And we need to check in what time this voltage will reach to 0. So you can put it 0 here. You can put it equal to 0 and calculate this t. So if you put it 0 here, then this VTH will go to the 0 side. It will become minus VTH. So it will be minus VTH divided by, take this in the denominator, minus of 5 plus VTH. Okay. This will be e to the power minus t over RTH into C. Okay. This minus minus will become plus. And if you take ln, so t is equal to RTH into C ln VTH plus 5 divided by VTH. This is the time. This is the time in which this capacitor voltage will become 0. We need to calculate this VTH and RTH and put it here. You can get the answer. Okay. So I think it's easy peasy. You can calculate VTH for this circuit and RTH for this circuit. Okay. Please do it yourself. I think it's easy peasy. You can check it. What I have done is I have replaced this network with VTH RTH and the capacitor is here. Initial voltage is -5 and the steady state voltage in this circuit is VTH. And the time constant is RTH into C. Okay. So I have written the equation VC infinity plus VC0 minus VC infinity e to the power minus t by tau. So this way we have written the capacitor equation, capacitor voltage equation. From this voltage equation I have calculated the time in which this capacitor voltage will become 0. That time is this. Now we need to calculate this RTH and VTH. Put the value of RTH, VTH and C. C is already known to us, 0.6 microfarad. Okay. So you can put the value of C, RTH and VTH, you will get the time. I think you can do it. Let's move to the next question. In this question, what is given is, okay, this is the circuit we have. It's a 2-port network. I need to calculate the admittance parameter. Okay. I need to calculate the admittance parameter. Now, be careful. Look. Which parameter is different in all the options? If you look at carefully, because I have to be selective. I want to calculate only one parameter. Okay, or 2 parameter. Using that I want to calculate the answer. Okay, I don't want to solve this question entirely. Okay, all 4 y parameter I have to solve and then I have to check. No, it's very lengthy, it's time consuming. So what I need to do is I need to check the options first. In Y11, if you look at carefully, Y11, 3 options have the same value and 1 is different. Okay, it means, let's say Y11 came out to be 2, then you will able to eliminate only 1 option. Okay, you'll able to have only, because which 2 parameter you can calculate easily? Either Y11 or Y21 or Y12 or Y22. Either you can calculate these 2 parameters directly or these 2 parameters directly. Now, first you look at only these 2 parameters. If I calculate, let's say Y11, and let's say Y11 came out to be 2. So you will be able to eliminate only 1 option. And then Y21. In Y21, again, you have 2 options in which you have -4 and 2 options in which you have -1. It means again there is a problem. There is a problem with this. But if you calculate Y12 or 22, in Y12, 3 options have the same value. Okay, let's say Y12 came out to be -4. Only 1 option is eliminated again, and then Y22. In Y22, this is the problem. We need to check. We need to solve. Otherwise, there is no, because I mean, with the options, I'm getting no point. Okay, I'm getting nowhere. Okay, so let's try to solve this. Now, how to solve this question? It's simple. First, let's calculate Y12 or Y21. How to calculate it? We know that. First, how to write the Y parameter? It's very simple. I1 is equal to Y11 V1 plus Y12 V2, and I2 is equal to Y21 V1 plus Y22 V2. Fine. Now let's calculate Y12 and Y22 first. How to calculate it? Put V1 equal to 0. It means sort it here. Okay, this is 0 now. And put V2 equal to 10 volt. Put V2 equal to, let's say, 10 volt. So I have put the value of V2. V2 has 10 volt. Now calculate I1 and I2. V2 is 10. So this I1 is equal to Y12 into 10 and I2 is equal to Y22 into 10. Okay, what we have done is we have put the value of V2 as 10 volt. Whatever, you can take it 20. Okay, no problem. So I have put the V2 as 10. Okay, now I need to calculate this I1 and I2, this current I2. Okay, that I1 upon 10 will be Y12 and I2 upon 10 will be Y22. Now let's calculate I1, this current I1. How to calculate this current? Since it is sorted, so there will be no current here. This is 0. This, via this resistance, there will be no current. Okay, we know that this is 10, and if I assume this is grounded, so this upper point will also be grounded. This will be 0. If this is 0, it is sorted here, so the upper point will also be 0. Is it fine? If it is 0, the upper point will also be 0, and this will be 10. Tell me guys, if this is 10, this current will be 10 ampere and this current will also be 10 ampere. Is it fine? 10 minus 0 upon 1. This will be 10 ampere, this will also be 10 ampere. So I2 will be 20. So I2 is 20. 20 is equal to Y22 into 10. Now tell me Y22. Y22 is 2. Y22 came out to be 2. Okay. So only two options are there. A option is there and C option is there. So B is wrong, D is wrong. Okay. We have eliminated two options. Y22 came out to be 2. Now let's come to I1. What is this I1? We know that this is 10 ampere and this is 30 ampere because V2 we have selected as 10. Na? So this is 30 ampere and this is 10 ampere. So this current has to be 40 ampere. So I1 came out to be minus 40. Okay. I1 is minus 40. So Y12 is minus 4. Y12 is minus 4. So in which option Y12 is minus 4? In both the option you have minus 4. Is it fine? So that's why you will not be able to find the right answer. Okay. Okay. So now what I need to do is I need to sort this side. Now I need to make V2 0 and I need to calculate Y11 and Y21. Then only you will get the correct answer. Okay. So first we have sorted this side and applied this voltage and calculated I2 and I1. I2 and I1. Okay. And then Y22 and Y12 are known to us. So using Y22 and Y12, either A or either C is correct. Okay. Now what I need to do is I need to check the other parameters also. Let's do it in a different way now. Now what I want to do is, so we have calculated these two parameters. Okay. Now it's time for the other two parameters, Y11 and Y21. So this time what I need to do is I will sort V2. I will sort it. Okay. V2 is 0 now. I'll sort it and you can put this voltage as 10 volt. Okay. Or 20, whatever. Let's call it 10 volt. Okay. Now calculate I1 and I2. This V1 is 10 now. So I1 is Y11 into 10 and I2 is Y21 into 10. Okay. Now calculate this Y11 and Y21. For that I need to calculate I1, I2. Okay. This is sorted. If it is sorted, there will be no current in this 1 ohm. The lower point is 0. So the upper point will also be at 0 because it is sorted here. Okay. And this side is 10 volt. Okay. Since V2 is 0, this current source is open circuit because this V2 is 0. This current source will not work. Okay. So now you can see that since this is 10, this is 0, this current is 10 ampere. So you can say that the I2 will be minus 10. I2 is minus 10. Y21 into 10. Okay. So Y21 came out to be minus 1. Now check in these two options where Y21 is minus 1. Here Y21 is minus 1. Here Y21 is minus 4. It means Agra is correct answer. Okay. So I don't need to solve for full circuit. Okay. So when you get this answer, try to eliminate the options. Don't try to solve the entire question. Okay. I hope you understood it. Okay. So this was again very simple. Let's come to the next question. In this question, a circuit is provided to us. The switch in the circuit in the figure is at position P for long time. Okay. The switch was at position P for long time. Now at t equal to 0, it is moved to position Q. Okay. It is moved to position Q, this position. Okay. At t equal to 0. I need to calculate dVt by dt as I need to calculate rate of change of this capacitor voltage at t equal to 0 plus. Okay. Now tell me, if this switch was at position 1 for long time, it means this circuit was working, the upper circuit was working. In this upper circuit, this was open, this was sorted. Okay. Now, if I open it, if I sort it, then the circuit will look like this. 5 kilo ohm. This is 20 kilo ohm. This is 20 volt. This is 20 volt. Fine. And here you have 5 kilo ohm. 10 kilo ohm. Fine. This inductor is sorted and this capacitor is open circuit. Is it fine, guys? 5, 5, 10, 20. And here you have 20 volt. Now, how much current will flow in this path? 5 plus 5, 10, 10 plus 10, 20. 20 kilo ohm is this resistance of this path. 20 divided by 20 kilo ohm is 1 milliampere. So via this path 1 milliampere current will flow. Now how much voltage across this 10 kilo ohm resistance? It's 10 volt. Okay, so this resistance has 10 volt across it, and this current is 1 milliampere. Inductor has stored this 1 milliampere current, and this resistor has 10 volt. Whatever the voltage across the resistor, same will be the voltage across capacitor, because inductor is sorted. So you can say that this capacitor is charged at 10 volt. Okay, so the capacitor is charged at 10 volt, and this current is flowing 1 milliampere. This current is 1 milliampere. Okay, this current is 1 milliampere, and the capacitor is charged at 10 volt. Fine. Okay, now what you did is you sorted here. Now the circuit will work like this. Now the circuit is like this. This is sorted here. Okay, so we have sorted, the P point is moved to Q. Okay, so the circuit will look like this. Is it fine? Now we have this initial current as 1 milliampere. Initial this current, and this voltage will remain at 10 volt. Now what I need to do is I need to calculate at t equal to 0 plus what is the rate of change of this voltage. What is the rate of change of this voltage? We know that C dV by dt, let's call it voltage Vt. We know that C dV by dt is ICT. This ICT. If somehow at t equal to 0 plus we can calculate this current, then we can put it here and divide by C, you will get dV by dt. Because we know that dV by dt is equal to ICT by C. Okay. So if somehow at t equal to 0 plus we can calculate this current, we can calculate the derivative value at t equal to 0 plus. Now what is this current at t equal to 0 plus? How to calculate this current at t equal to 0 plus? So you have to calculate it. Now tell me, at t equal to 0 plus this current is 1 milliampere, that's for sure. And this voltage, if I assume this as ground, this voltage will be 10 volt, and this is 5 kilo ohm. This voltage will remain at 10 volt because this capacitor will maintain this voltage. Now how much current it will flow in this direction? 10 minus 0 divided by 5. So it will be 2 milliampere. So at 0 plus, this current will be 2 milliampere, this current will be 1 milliampere. So this ICT has to be minus 3 milliampere because it has to be upward. It has to supply this 1 and this 2. So you can say that IC is at 0 plus, this current is minus 3 milliampere. Divide by C. C value is 1 millifarad. So that milli cancel. So you'll get minus 3. Is it fine? So this dV by dt at t equal to 0 plus is minus 3. Okay. So this is again an easy problem. Okay. You take this C in the denominator. You can calculate ICT at 0 plus. This current at 0 plus. Because this is the positive polarity. According to the positive polarity, this downward current is positive current, ICT. So we have to calculate this IC 0 plus. We know that at t equal to 0 plus, this will take 1 milliampere current because it will maintain its current. So at 0 plus, this current will remain at 1 milliampere, and this current will be 10 because this voltage is maintained at 10. 10 divided by 5. So 2 milliampere current. 2 on this side, 1 on this side. So IC has to provide, capacitor has to provide 3 milliampere. So IC is negative now. Okay. Minus 3 milliampere is the IC 0. Divided by C. C is 1 millifarad. So milli is cancelled. So you can say that it's minus 3. Okay. So at t equal to 0 plus, this dV by dt is minus 3. I hope you understood it. Let's move to the next question. Question number 16. Now in question number 16, consider the circuit shown in the figure. The value of V naught. Value of V naught. Okay, this voltage I need to calculate. So how to calculate this voltage? It's very simple. Make it 0, and V naught is the voltage across this one. So if this is 0, this point will become V naught only. This point will become V naught only. Is it fine? This point is V naught. Now this is 6 milliampere and this is 2 milliampere. So obviously this current will be 4 milliampere. No, 8 milliampere. Yes, 6 on this side and 2 on this side. So this current will be 8 milliampere. Is it fine, guys? This current will be 8 milliampere. Now what I need to do is I need to apply direct nodal here. So apply the direct nodal, coefficient of V naught. Assume that here you have a current source because this current is constant now. So don't consider this branch. Imagine that this branch has a current source that has 8 milliampere value. So this branch current is fixed. So we will not use this resistance anywhere. Okay. So now what is the coefficient of V naught? The coefficient of V naught is 1 upon 1000 plus 1 upon this 1000 equal to entering current. Now tell me the entering current. On this side, the entering current is 4 divided by 1000 plus, on this side it is leaving 8 milliampere. So 8 upon 1000, it's leaving. That's why I have to take it minus. Okay, minus. And from this side it is entering. So plus 6 upon 1000. Okay, so it will be 10 minus 8. So on this side you have 2 upon 1000 and V naught, here you have 2 upon 1000 again. So you can say that V naught came out to be 1 volt. Okay, this came out to be 1 volt. Okay, is it fine, guys? I don't know how many of you understood it. Let me tell you, this is 6, this is 2. So this will fixed at 8. It means you can treat this branch as a current source, and the value of the current source is 8 milliampere. And this voltage is V naught. So now I can write the direct nodal equation. The coefficient of V naught is 1 by 1000 plus 1 by 1000. It has current source. This branch also has the current source. So I'm not going to write it. Okay. So 1 by 1000 plus 1 by 1000 equal to entering current. Entering current from this side is 6 milliampere. So 6 upon 1000. It is leaving. So minus 8 upon 1000. And this 4 volt will try to enter the current. Okay. It will try to give the current in upward direction. So 4 divided by 1000. Okay. So this way we have calculated V naught. V naught came out to be 1 volt. Is it fine? So direct nodal, I mean, it will save your time. Now let's come to this question. For the value of V naught, okay, we need to calculate the value of V naught. Where is the value of V naught? No. We don't know where V naught is. The current I flowing in 7 ohm resistor between P and Q. Okay, we need to calculate I, huh? We need to calculate I. Okay, this is not the question, guys. Okay, yeah, this is typing mistake. We need to calculate the value of I. We need to calculate this value of I. What is this value of I? Okay, how to calculate this value of I? Tell me, guys. Let's assume that this is 0. Okay, this is 0. If this is 0, we can assume that this is VA. It will be VB. It will be VC. So we have 3 unknowns. You can see that. We have 3 unknowns. Now, how to... No. If this is VA, this is also VA. This is sorted here. Wait a minute, guys. This is also VA. Okay, if this is VA, this is also VA. So what you can do is, better you combine it, no? But you simplify it. Because this 6 and this 3, they are in parallel. So simplify it. Let's simplify it. Start with Q point. You have this 2 ohm and this 2 ohm. They are in parallel. Because this VA, they have same point. And this point is also same. So 2 and 2, you can replace this 2 and you can replace this 2 with 1 ohm. Is it fine? This is 1 ohm. Okay. And this is the current source. Current source of 5 ampere. Okay. So now I have removed this 2 ohm and combine it with this 2 ohm. It will become 1 ohm. Now this 6 ohm and this 3 ohm, look, they have the same endpoint, and this VA and this VA is same. So you can say that 6 and 3, they are in parallel. So make it parallel. So if you take parallel 6 and 3, it will become 2. It will become 2 ohm here. Okay. I have removed this 6, and 6 in parallel with 3 will become 2. Okay. And here you have 7 ohm. Here you have 7 ohm. Is it fine, guys? I need to calculate this current I. I think it's easy peasy. I think it's easy peasy now. Now, what is this value current? Look, this is 9 ohm and this is 1 ohm. So this current will divide in 2 paths. Via this and via this. Whatever current will flow, I mean, we need to calculate this current I. So I will be equal to 5 into, tell me, 5 into this branch divided by the total resistance. 9 in this branch, 1 in this branch. So 10. So it came out to be half ampere. Is it fine, guys? It came out to be half ampere. Sir, how to use virtual calculator for complex calculation? I have already told you. Maybe in some other video I'll tell you, Bruce. Okay, I'll tell you in some other video. Okay, so the answer came out to be half ampere. You have to just simplify this circuit now. Okay, then you can solve that this current came out to be half ampere. दिस इज इजी पीजी। साहिल सोनी, सर जी वासु जी बोल रहे हैं गेट पोस्टपोन होना मार्च में होगा, प्लीज टेल रियलिटी सर। ओ यार वो पागल आदमी है, ठीक है, उसको व्यूज चाहिए और उसको कुछ नहीं चाहिए, उसको बच्चे से कोई लेना देना नहीं, उसके जेब में पैसे आ गए हैं, मूर्ख बना रहा है वो तुमको। क्यों पागल हो रहे हो भाई, ठीक है, पागल बना रहा है वो, ठीक है, ये मत करो भाई। वासु है भैया, एक वासुदेव पौंड्रक है एक, ठीक है, वासुदेव पौंड्रक, वो कहता है मैं ही प्रभु हूं, मैं गॉड हूं, ठीक है, वो ये बोलता है मैं प्रभु हूं, ठीक है, तो वो मूर्ख बना रहा है आपको, ठीक है ना, तो उसको ध्यान मत दो भैया। लास्ट ईयर भी उसने बेवकूफ बनाया था बच्चों को, ठीक है, इमोशंस के चक्कर में बना बना के इमोशनल फूल, ठीक है। वो गेट में सबसे अगर कोई खराब बंदा है ना, कोई जो सबसे ज्यादा बेवकूफ बनाता है लोगों को, तो वो वासुदेव पौंड्रक है, ठीक है, मैं आपको बता देता हूँ, ठीक है, अब आप समझ जाओ, ठीक है। टाइम वेस्ट कर रहा है बिल्कुल, और कुछ नहीं कर रहा वो, ठीक है, टोटल टाइम वेस्ट, आपको करना है टाइम वेस्ट, मजे लो वहां पे, ठीक है, नहीं तो भैया पढ़ लो, ठीक है। चले भाई आगे बढ़ते हैं। मे भी जा सकता है सर, क्या जा सकता है, मे भी जा सकता है, मे में भी जा सकता है, अच्छा ऐसे बोल रहा है क्या यार, तुम अपना समय खराब करना कर लो, ठीक है, सीधी बात है, ये सब क्या है, फालतू बकवास है ये सब, मैं बता रहा ना, वो बंदा बकवास मार रहा है, ठीक है, फ्रॉड आदमी है, मैं पहले बता रहा हूं, ठीक है, जो तुमको करना कर लो, ठीक है, मैं खुल के बोल रहा हूं, फ्रॉड आदमी है, इस गेट इंडस्ट्री का जो सबसे महाफ्रॉड है ना, तो वो वासुदेव पौंड्रक है, ठीक है, अब आप समझ जाओ, ठीक है, तो इसलिए सिंपल है भाई, उसको बच के रहो, ठीक है। हाँ जी, वो अप्रैल नहीं, वो मेरे ख्याल से वो 13वां महीना निकाल सकता है वो कोई बंदा, वो ऐसा बंदा है जो 12 महीने छोड़ के 13th मंथ निकाल सकता है, जैसे जनवरी फरवरी मार्च अप्रैल मई जून जुलाई अगस्त सितंबर अक्टूबर नवंबर दिसंबर, ठीक है, वो कोई गेट एम्बर भी निकाल सकता है, कोई ऐसा कोई 13th मंथ क्रिएट कर सकता है, वो ऐसा आदमी है, ठीक है। तो मैं तुमको बता देता हूं, कोई ऐसा 13th मंथ आ जाएगा गेट एम्बर, ओके, उस मंथ होगा गेट का एग्जाम, ठीक है, तो तुम समझ जाओ अब क्या है वो फालतू। आइए भाई आगे बढ़ते हैं, नेक्स्ट क्वेश्चन देखिए। सो द नेक्स्ट क्वेश्चन इज now for the circuit shown the locus of the impedance ZW. Now I need to check the locus of this diagram, okay, as omega increases from 0 to infinity, omega varies from 0 to infinity, I need to check the locus. Now how to check it, it's very simple. At omega equal to 0 it will be purely resistive, okay, if it is purely resistive its value will lie on the real axis, okay. Now at omega equal to infinity again its value will be purely resistive, this capacitor will be sorted, okay. At omega equal to infinity the reactance of the capacitor will become 0, it will be sorted here, so the impedance will be purely resistive R1. And omega equal to infinity this is open circuit, then again the impedance will be purely real, it means at omega equal to 0 also it will remain on real axis, omega equal to infinity it will remain on real axis. Now at omega equal to 0 you can see that the impedance is R1 plus R2, it will be more, it will become 5, okay. At omega equal to 0 it is given as 5, so it means R1 plus R2 is 5, okay, R1 plus R2 came out to be 5, is it fine guys? And at omega equal to infinity is 2, at omega equal to infinity we know that this is sorted, so the only impedance is R1, okay, because it is sorted, so the input impedance is R1 only, so R1 came out to be 2, R1 came out to be 2, so put the value of R1 and calculate the value of R2, R1 came out to be 2 kilo ohm and R2 came out to be 3 kilo ohm, is it fine guys? Answer is Agra, is it fine, tell me. IIT प्रोफेसर से भी ज्यादा नॉलेज है बोलते हैं, गुड यार, टाइम पास मत करो यार। साहिल आकाश सिंह, सर सारे क्वेश्चन सीरीज की प्लेलिस्ट बना दीजिए जो पहले भी हुई है, जैसे ढूंढने में आसानी हो सके। यार ये आप लोग बना लो आकाश। Let's come to the next question. So I told you that this question is again very simple. It is given that omega equal to 0 it's 5 kilo ohm and at omega equal to infinity it's 2 kilo ohm. So at omega equal to 0 it is open. So if it is open the Zin is R1 plus R2. So R1 plus R2 came out to be 5 according to this point, and at omega equal to infinity this is sorted. So Zin will be equal to R1 only because this will be sorted, na? So Zin is R1 only. So R1 came out to be 2 kilo ohm now. Okay, so put the R1 value and you'll get R2 equal to 3 kilo ohm. Answer is Agra. Let's come to the next question. Question number 19. So in question number 19, consider the circuit shown in the figure with the input VT as VT is sine T. Okay, this is 1 ohm and this is input impedance. This is some Z. Okay, the sinusoidal steady state current IT is flowing. So this is IT and IT shape is like this. Okay, IT shape is like this. And what is given is, wait a minute, IT flowing through the circuit shown graphically where T is in second, the Z element is. What is this Z? He's asking that Z. Okay, he's saying that this current, this point is at pi by 4. This point is at pi by 4. Okay, T is equal to pi by 4. This time is pi by 4. It means the zero crossing of this current lies at pi by 4. It is, I mean, it means the zero time will lie here, na? So the zero crossing will be lagging. The zero crossing of the current comes at pi by 4, 45 degree lagging. Now the current will lag only if this Z is purely inductive. Okay, only if the current is purely inductive. Is it fine? So the Z must be inductive. Okay, purely inductor, and it must be of 1 Henry, so that it will become J1, so that the impedance will become 1 plus J1, and the now current will become 1 angle 0 divided by 1 plus J1. So it will become 1 by root 2. So you can see that the peak value is 1 by root 2 ampere, na? Because the voltage peak value is 1 volt and this is 1 ohm. If it is J1, then you can see that the current amplitude is 1 by root 2 and it will lag by 45 degree. Okay, so you can see that the zero crossing is at pi by 4. Okay, so you can say that this Z will be purely inductive and its value should be of 1 Henry because omega is 1. This is J omega L. Omega L is equal to 1. Since omega is 1, L is also 1 Henry. Okay, so answer is Bombay. Answer is Bombay. Let's move to the next question. In this question, what is asked? The current I in the circuit shown. Okay, we need to calculate this current I. How to calculate this current I, guys? Tell me. Okay, we can apply nodal. Okay, this is 0. It is provided to us. Let's call it VA. If somehow we can calculate VA, then we can find this current I. So write the direct nodal equation. The coefficient of VA will be, what is the coefficient of VA? It's 1 by 2000, 1 by 2000 plus 1 by 2000, this 1 by 2000 plus this one. We will not write this 1 by, because current source is there, is equal to entering current. Entering current is 10 to the power minus 3 from this side plus 5 upon 2 into 10 to the power minus 3. Okay, this is the entering current on this side. So VA upon 1 upon 1000 is equal to, I have added this, na? So you will get 1 upon 1000 is equal to, if you are going to add this, it will be 3.5 into 10 to the power minus 3. This 10 to the power minus 3 is cancelled with this. So VA came out to be 3.5. Okay, this voltage is 3.5. Now, how to calculate this current? It's very simple. 5 minus 3.5 divided by 2000. Okay, so it will be 1.5 upon 2000. Okay, 1000 I have represented milliampere. So came out to be 0.75 milliampere. I is 0.75 milliampere. Answer is Bombay. Okay, 1 Henry आपने कैसे assume कर लिया? मैंने assume नहीं किया. Okay, मैंने assume नहीं किया. Look, it is given that the current zero crossing is at pi by 4. It is given, it is provided. It means current zero crossing is lagging. It means the origin line is somewhere here and the zero crossing is at pi by 4 second. It means current is lagging. If current is lagging, it means it's an inductor. That's correct, because here you have resistor. It means it should be an inductor. So it is an inductor. Now, what is the inductance value? What is the impedance value? How to calculate that? We know that the amplitude of the current is 1 by root 2 and the voltage amplitude is 1. It's 1 sin t. If the voltage amplitude is 1 angle 0 and resistance is 1, and I have to make this amplitude as 1 by root 2, peak value has to be 1 by root 2, and angle has to be minus 45 degree. Current should lag by 45 degree. It means current should be at minus 45 degree. Now, I have to take this Z as J1. Then only the amplitude of the current will be 1 by root 2 and it will lag by 45 degree. Okay, that's why I have taken this Z as J1. This is the reactance. Reactance is J omega L. So omega L has to be 1. And omega is given as 1. Sin t. Sin t. What is the meaning of sin t? Sin t means omega is 1. So if I put omega equal to 1 here, L is equal to 1. Okay. So this way you can calculate the value of L. Now this question was again very easy. Let's come to the next question. Okay. In this question, this I is asked. What is this I? I is 0. 0 ampere. Why it is 0 ampere? Tell me guys. Because this is a closed circuit. In this closed circuit, if there is some entering current, there must be some leaving current, but there is no return path. There is no return path. So you can say that I is 0. Okay. No need to solve this question. I is 0. Tell me guys. Okay. Complex calculation कैसे करें? वो यार किसी अलग वीडियो में बताएंगे आपको. ठीक है साहिल जी, किसी different वीडियो में बताएंगे. Okay. That's all. Congratulations. Okay. So we have covered all the PYQs from last 5 years from EC background and also from EE. The previous session was for EE, the yesterday's session, and today's session is for ECE. Okay. Now one question was very good according to me. If I going to judge this last 5 year questions, let me tell you guys, this question was very nice. Yes, this was the question. This was very good question. Okay. Please try this question again. This was very good question. Okay. Because this question, even I took 30 minutes. Okay. And I took 30 minutes. I don't know, 30 or maybe 25 minutes. I took that much of time to solve this question because, and in this problem, I told you why you can't apply Laplace transform, because there are many students who think that we can take the Laplace transform this RT, we can take the Laplace transform of C, okay, and we can take the Laplace transform of this and you can solve it. No, you can't do it because this is time variant circuit. This is linear time variant circuit. Since it is linear time variant circuit, you can't apply Laplace transform here. Okay, that's why we have solved it via simple KVL equation. Okay, so first we have written the KVL equation, then I have removed this integration sign. How I have removed this integration sign? By taking differentiation on both sides. Okay, if I take the differentiation on both sides, I'll get this. Okay, then I did this and then I separated the variable. Okay, now variable separable form. Look, from network theory I went into mathematics, and this maths is, I mean, generally the network theory teacher don't teach network theory, don't teach mathematics. Okay, even I don't teach mathematics because I teach only some topics of mathematics. So it might be possible that I don't know how to solve this differential equation in variable separable form, but luckily I know this because when I watched this and then I got the idea that okay, we can solve this by variable separable and we can take we can solve it like this. Okay, so this way we can solve it, and this is very good question. Okay, so please remember this is a linear time variant circuit. Anyway, sir, कोई variable quantity होता तो Laplace apply or no? No, we can't apply Laplace transform like this question. No? In this question, RT is variable, resistance is variable. Resistance is varying with time. If resistance is varying with time, it means this circuit is not LTI. This circuit is time variant. Okay, this differential equation is not linear differential. Yes, it is linear differential equation, but it is a time variant differential equation. Okay, this is time variant differential equation. Okay, so it's not LTI system. This is not LTI system. If it is not LTI system, then it will be very difficult to solve with Laplace. Okay, it's very difficult to solve with Laplace. If you apply the Laplace transform, it will be very difficult to solve it. Okay, that's why we will go to time domain analysis only. We have to solve this equation in time domain only by using variable separable form. So this was again a very, very good question. Even whoever has made this question, whatever IIT professor or whoever made this question, I think is very good. Okay, he know the concept very well. Okay, so this is again very good question. Anyway, so only this question was challenging. Only this question was challenging. I think other questions were very easy and you can easily solve the question. This was again very good question because in this question he has mixed the network theory with control system. Okay, network theory with control system. So this is again a very good question. Okay, please try to look at this question also. Differential equation का कोई limitation है क्या सर? नहीं, कोई limitation नहीं मैं बता रहा हूँ. I'm telling that you can't solve it by using Laplace. Okay, Yes, you can use it Laplace theory, but then it will be very complicated. Okay, that's why I'm not trying to solve it via Laplace transform. Okay, so just remember this point. So I told you ki now this question was again very good question. It was mixed with control system, so you can solve this question also. Okay, so बाकी तो सब आसान था. Okay, बाकी सब easy था यार. So I hope you enjoyed. Okay, सर ये कोई बुक का है क्या सर? नहीं, बुक का नहीं है भाई. ठीक है, ये बुक का क्वेश्चन नहीं है. ये बहुत अच्छा क्वेश्चन था. ठीक है ना, ये दो क्वेश्चन बहुत अच्छे थे भाई, है ना. सो प्लीज ट्राई टू मतलब इन क्वेश्चंस को देखिएगा, इनको सोल्व करने की कोशिश कीजिएगा. ओके, एंड आई होप यू एंजॉयड दिस सेशन. सर कॉम्प्लेक्स कैलकुलेशन शॉर्ट में बता दीजिए. यार कोई शॉर्ट नहीं है उसका कोई. ठीक है, बहुत सारे वीडियोस पढ़े, आप देख लीजिए कि कॉम्प्लेक्स को कैसे सोल्व करें वर्चुअल कैलकुलेटर पे. मेरे हिसाब से लेट्स से लाइक ऐसे आ रखा है 20 एंगल 30 प्लस 40 एंगल 60 ऐसे आ गया. तो आपको इसको सोल्व कैसे करें वर्चुअल कैलकुलेटर पे? सो व्हाट यू कैन डू इज यू कैन टेक द रियल एंड द इमेजिनरी पार्ट, because you can't put in virtual calculator directly. So what you can do is you can take the real part 20 cos 30 plus 20 j 20 sin 30. Similarly 40 cos 60 plus j 40 sin 60. Okay, and calculate the real part and the imaginary part. Okay, calculate the real part and the imaginary part. Once you get the total real and the total imaginary, then again you can convert the magnitude as r square plus x square and take angle as tan inverse of x by r. Now you can separately you can calculate this ना, you can calculate this value in virtual calculator. तो आपको वो calculate करनी है. Now what is this r? Real part का sum. Real part का sum जो है वो r है and imaginary part का sum जो है वो x है. So what you can do is आप उसका square ले लीजिए, sum कर दीजिए, तो आपके पास ये मैग्नीट्यूड आ जाएगा वर्चुअल कैलकुलेटर से. सो सेपरेटली यू हैव टू सोल्व. ओके, सेपरेटली यू हैव टू सोल्व. इज इट फाइन? हाँ, सेपरेटली यू हैव टू सोल्व. सिमिलरली आपको tan इनवर्स x बाई आर करके उसका एंगल निकाल लेना है. सो रिजल्टेंट का एंगल भी आ जाएगा. बट आप दोनों को एक साथ नहीं पुट कर सकते हो. सो उसमें ये थोड़ा सा चैलेंज है, बस ये थोड़ा सा प्रॉब्लम है. ओके सर, कुछ लोग बोलते हैं कोई डेटा याद कर लो. क्या डेटा याद करना है? कुछ याद नहीं. अपना नाम याद रखो बस, अपने पिताजी का नाम याद रखो, अपनी माँ का नाम याद रखो, अपने गांव शहर का नाम पता होना चाहिए बस. आई थिंक इतना काफी है. ओके, इतना कर लोगे बहुत है. ओके, सो दैट्स ऑल फॉर टुडे सेशन गाइस. आई होप यू एंजॉयड. सो पढ़ते रहिए, मुस्कुराते रहिए. नेक्स्ट सेशन में मिलेंगे. कल सेशन है मशीन का, इलेक्ट्रिकल स्टूडेंट के लिए है. और इलेक्ट्रिकल स्टूडेंट के लिए कल मेरा जो टॉपिक है वो है, मैं क्वेश्चंस कराऊंगा PYQs इंडक्शन मशीन के. ओके, इंडक्शन मोटर. सो कल इंडक्शन मोटर के क्वेश्चन सोल्व करते हैं. ओके, सो थैंक यू एंड थैंक यू फॉर शोइंग इंटरेस्ट इन दिस क्लास. टेक केयर. मिलते हैं फिर कल 9 बजे. 9 बजे आई डोंट थिंक 9 बजे है, 11 बजे है कल का सेशन. ओके, सो कल मिलते हैं. टेक केयर. बाय.